The Falcon Heavy, once we start tanking, will then be locked in to that launch time, and that is an instantaneous window. We are awaiting a poll at T minus 57 minutes where the NASA launch manager will check with his team and then feed back to the launch director, Mike Taylor, with SpaceX today. Tell us a little bit about that poll.
Yeah, Daryl, we've talked this in previous broadcasts on many missions. You and I have worked together, but launching a rocket is a team sport, and there are many teams working different things from engineering to analysis to the spacecraft team to our Space Force partners, and of course our commercial partner SpaceX, who's providing the launch vehicle this morning and running this launch operation. And NASA's launch manager Tim Dunn will do his NASA poll, which means he will check in with the NASA engineering team and the spacecraft team to make sure they are ready to get into propellant load. And then he will report out, as you said, to launch director Mike Taylor, who's running the SpaceX team, to start that propellant load. So far, all of that operations are looking good, and I'm excited to wait and hear that poll, because once we start loading this propellant in the vehicle, we have a really good chance that we're going to lift off today.
That poll coming in 1 minute and 45 seconds, currently T minus 59 minutes and 40 seconds and counting. Once we get the go, and we expect, because we're not hearing anything so far, that it is likely to get a go, we'll begin tanking at T minus 50 minutes. And that will start with RP1 load. After that, will be followed with the LOX load at T minus 45 minutes, then stage 2 RP1 at T minus 35 minutes, and then the LOX load of stage 2 at T minus 18 minutes.
Yeah, absolutely. We stagger those load times to make sure we get things going, make sure we get RP1 into the tank and start flowing first prior to putting that densified LOX in there onto the first stage. What's unique about the Falcon Heavy, Daryl, we've talked this a little bit too, right, you and I, that unlike a single stick Falcon 9, which starts at T minus 30 minutes, with the Falcon Heavy, we have 3 booster cores that we have to load. So we back that time off a little bit so we can make sure we can get all the propellants loaded into all 3 first stage boosters at the same time. And then once that starts and LOX load on the boosters are completed, we then will start moving into second stage load to provide a stable structure of the launch vehicle standing out of the pad.
And if we launch today, Mick, it will be the 8th launch of Falcon Heavy, the first one in 2018. Overall for SpaceX, the 267th launch, but it is the first launch on a Heavy for NASA on a planetary mission.
Yeah, we're excited to be partnering with our commercial partner SpaceX on this Falcon Heavy. It's our first Heavy mission that we have worked with them. We have worked many missions so far with SpaceX on some very important scientific discoveries that we have done with NASA, but this one being a first Heavy for us. The Heavy was required to get Psyche on its way on the trajectory that's needed to get out to the asteroid and provide the performance and power needed to make sure that the mission is a success and that we get all the science that the team is looking for. And this science team has spent a lot of time putting this satellite together, and this is going to be not only great excitement for us on the launch today, but excitement for the spacecraft team to finally see Psyche off doing what they've designed it for.
All right, let's listen in now as we listen for SpaceX launch director Mike Taylor to poll NASA launch manager Tim Dunn, the highest NASA authority on the launch today.
We are currently tracking no COLA conjunctions for our T0 opportunity. That was also very good news. Both the upper level winds and recovery numbers are all in line, so it looks like a good day. But I would like to now poll the NASA JPL Psyche team for their readiness for propellant load and launch readiness. NASA CE.
NASA CE, go.
SMA.
SMA, go.
SMD.
SMD is go.
NASA MEM.
NASA MEM, go.
LSP.
LSP's go.
In limb copies, the NASA Psyche team is go for propellant load and launch readiness.
Okay, good news there. Polling all go for the NASA team. I want to correct something I said. I said that it was going to be Mike Taylor from SpaceX. His poll actually comes up later on.
LM.
We have LDA clear to launch, and want to confirm you're ready to meet me on countdown net to give final go for propellant load.
That's affirmative.
So
launch manager, LD, countdown net, confirming government team is ready to proceed with propellant load.
LD, this is NLM. The NASA team is ready for propellant load and continued countdown.
Copy NLM. So at this time, the integrated SpaceX NASA team is go for propellant load and launch. A reminder, on aboard instructions. For non-urgent no-go conditions, brief CE or LD, and it will approve aborting the countdown. For urgent issues affecting the safety of the operation, operator shall call hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed to the launch abort auto sequence. Finally, at T-minus 10 seconds, launch control will be hands off and relying on automated abort criteria for the remainder of the count.
okay, great news, great call out there. As all teams reported go for the beginning of tanking at T-minus 50 minutes, just about 4 minutes from now. Mick, you understand the structure of that poll. Kind of highlight it for us.
Yeah, so NASA's launch manager, Tim Dunn, as I was saying earlier, he confirmed with his NASA engineering team, his safety and mission assurance team, his spacecraft team, and the LSP program team to make sure that the NASA government team was ready to start propellant loading. And then shortly after that, we heard Launch Director Mike Taylor confirm with the NASA launch manager that the NASA government team is ready to proceed into propellant load and they're working no issues. Tim Dunn reported there are no COLAs for today as we talked, and everything is looking good. The team is working no issues at this time, and all systems have checked out nominally up to this point. The automatic FTS system checks were complete. The hold fire communication checks with the Space Force were completed. And so everybody's go, and then Mike Taylor briefed his team over the countdown net that they would continue moving forward to get ready for propellant load at T-minus 50 minutes.
This poll carrying a bit more weight than the poll usually does in this circumstance because of, as I understand it, the tanking of the Falcon Heavy. According to the launch team, you can only get 2 full attempts if you go all the way down to T0 before you have to take LOX load. So they really wanted to be sure that the weather was good and the range was good before they start tanking, because once you start tanking, now you've committed to basically burn a day to try and get a launch off.
Yeah, we're talking ground storage of LOX. The amount of liquid oxygen that the Launch Complex 39A has on storage, the tanks are completely full right now. And with the amount of liquid oxygen that are in the storage tanks, we can get 2 full launch attempts out of that liquid oxygen storage tank. Once we start tanking the vehicle, we have that boil off as we see the plume from the vehicle. You see the LOX, the cold
vehicle tanks
liquid
are venting
oxygen,
for the start of propellant load.
Condensing and boiling off from the temperature change between the Florida air and the LOX vehicle. And once that starts boiling off, we lose some of that liquid oxygen. So if we were to stand down for today, we would detank the vehicle, put that back in the storage tank, and we would have less than we started with. So we have to take that into consideration when we get ready for this count. And the team did that here at the go, no-go point, and they are ready to start loading LOX this morning for an attempt.
The good news is in the past 4 attempts, or the past 4 launches, I should say, of the Falcon Heavy, they launched on either the first or the second day. So it's unlikely that we would get all the way down to a T0 2 days in a row. But in case we do, it's good to know that we do have to take 5 days to reload all the LOX and give it another attempt. This also has a bigger context in terms of the planetary window that we are in. which is a 3-week window, and it has to be launched within this window, Mick, or they don't make it to Psyche. They wouldn't launch.
Yeah, that's correct. The Psyche window, launch science window, is about that 3-week period, and each day within that period, we have a 1-second opportunity each day to do that. So that is really critical for the team to look at everything and make sure they're ready to go when they go into this propellant load, so that they can get that window.
All right, let's listen in as the launch auto sequence is expected to start at T-minus 50 minutes. We'll sign off for now and leave you with the loops that you'll be hearing throughout the rest of the broadcast.
The launch auto sequence has started.
Probably 2 million asteroids in our solar system.
The reason that Psyche is unique is that it is metal rich.
It's believed that it may be a remnant core of an early planetesimal.
One of the ingredients that went into making our Earth, and one that we cannot see any other way. And it would be the first metal object that humankind has ever visited.
Studying the evolution of a planetary body is a detective story.
I think the only thing we know is that it's not going to look like what we think it's going to look like, and it's going to be really interesting, whatever we find.
Space is always more amazing than we can imagine with our minds.
You're looking live at NASA's Kennedy Space Center's Launch Pad 39A. Fueling of that SpaceX Falcon Heavy rocket should have began a couple of seconds ago for the Psyche mission to a mysterious metal asteroid. Welcome, and thank you for joining us live from the Space Coast of Florida for this first of its kind mission. I'm NASA's Megan Cruz, and this is Jim Bell, a professor at Arizona State University. Great to have you here.
Spectacular, great, good morning. Launch day, super exciting.
You have a lot of excitement, and I'm glad to see it.
Yes.
As he said, launch day, so liftoff is targeted for exactly 10:19 and 43 seconds Eastern Time. The name Psyche refers to the spacecraft we're launching today, but also the asteroid we're sending the spacecraft to. And we actually have a model of the asteroid right here, a very baby model.
Tiny model, right?
A lot smaller than the real thing.
Yes, the real asteroid is about as wide as the state of Massachusetts, so it is a very, very large asteroid. It was discovered in 1852 by an Italian astronomer, and he named it Psyche after the Greek goddess of the soul.
Beautiful name.
Yeah, so because of that, we named our spacecraft Psyche. And because of that, we named our mission Psyche. So the focus is on Psyche.
Yep.
We're really focusing on really getting to know this little world.
All makes sense to me, easy to remember.
Yes.
So as you place that asteroid down, tell me where Psyche is in relation to us and our solar system.
Right, well, you remember elementary school, right? Mercury, Venus, Earth, Mars, Jupiter, right? And between Mars and Jupiter is the main asteroid belt. And this asteroid orbits in the main asteroid belt between Mars and Jupiter about 3 times as far from the sun as the Earth.
And really quick, a very unique asteroid, obviously, metal rich.
It's metal rich, and it's the largest one of its kind in the entire solar system.
And that's why we're going to
yes.
it. And there is a lot to learn about this mission. That's why Jim and I aren't the only ones you'll hear from today. We have Jasmine Hopkins here at Kennedy Space Center at a nearby viewing location, Raquel Villanueva at NASA's Jet Propulsion Laboratory in California, and Daryl Nail and Mick Woltman, who will walk us through the operational milestones today. All right, so guys, SpaceX has been fueling its Falcon Heavy rocket for about a couple of minutes now. And the other watch item is, of course, the weather today, but we are looking a lot better than yesterday.
Yes, we certainly are, Megan and Jim, and good morning to you both who are looking lovely in your purple and orange mission colors. Mick and I here, we're in our gray, which was the weather yesterday, but you know, great news in terms of the weather for today's launch. It improved to 85% go. We just heard a weather brief, as she gave that brief to the launch director, Mike Taylor of SpaceX, and you can see it on the graphic there. 85% go. Winds are light and variable. 5 to 10 miles per hour out of the west. Temperature 82 degrees, and of course it's humid. Our only concern, though, Mick, a potential cumulus cloud in the area. We don't have any rain, as you can see on the radar. That's the best news that we got today.
Yeah, absolutely. Like Jim, I'm excited this morning. I mean, we started early this morning, Daryl, you and I listening to the nets, and the weather has only improved over the last several hours down to this 85% go, and I'm excited for that as we move into launch liftoff this morning. The range team will continue looking at the weather, and along with the engineering team on the launch vehicle, but things are looking really good this morning from a weather standpoint for this mission. I'm very excited.
The other major factor for consideration before launch is the range. As you look at a beautiful shot orbiting around the launch pad there at Launch Complex 39A, the Falcon Heavy, the 3 boosters at the bottom, and the spacecraft Psyche encapsulated at the top. That range, as you can get a look around over the Atlantic Ocean, is green, so we're good to go there. Listen now.
NY, PY, and center core LOX load has started.
That is the call out for LOX load. So now we were flowing RP1 propellants into the Falcon Heavy boosters, those 3 boosters at the bottom. Now we are flowing LOX, which is more of a delicate operation.
Yeah, absolutely. About 5 minutes ago, we started the RP1 load, which got the fuel going into the boosters, and now we are putting the cryogenic densified LOX in board. Between the 2 propellants, that will provide all the fuel and energy needed to fire the 27 Merlin engines this morning. So the team is loading the first stage, and about 5 minutes from now, we'll start loading second stage. So things are looking really good, and nominal instrumentation on all the load.
We are counting down to a T0 at 10:19:43 a.m. Eastern Time, 14:19:43 UTC time. It is an instantaneous window now that we've started LOX. Real quickly, Mick.
Yeah, absolutely. We starting this densified LOX, it sets our window for this morning because we've committed to that, because we have to maintain that cold temperature of the densified LOX in the stage. So the team is confident. They've given the go. We've started propellant loading, and we're looking forward to liftoff.
All right. Our next call out will be for propellant load in the second stage of the rocket. That's coming up in just about 10 minutes. But for now, we'll send it back to Megan and Jim.
Wow, what do you think of those live views from the helicopter?
Daryl and Mick are awesome, too. It's great to have these experts.
We're awesome, too. Yeah, it was really great to see those shots, not, of course, of the rocket, but also the weather, 85% go.
It's been our biggest concern, right? The spacecraft is ready, the rocket is ready, the team is ready. Let's hold out for the weather.
Yeah.
It's looking good.
Looking good, exactly. Now, you heard that call out over the loops about loading liquid oxygen. You're going to hear call outs like that throughout the broadcast, and we're going to pause for those so that you can follow along with operations. Our broadcast today will take us all the way through the moment we deploy and get the first possible signal from the Psyche spacecraft. Now, Jim, people might be wondering why go to a metal-rich asteroid?
Well, we've visited over 60 or more years of NASA and other space agencies. We've visited gas planets and rocky planets and icy moons and comets and rocky asteroids. We've never seen a metallic asteroid. There's a big population of them out there. Psyche is the largest one.
Right.
So we want to study this class of objects that we've never seen up close in the solar system.
And so what do we hope to learn by studying Psyche?
So one hypothesis is that Psyche might be the preserved ancient core of a little planet, a planetesimal. And so we can't study the core of the Earth, right? It's too hot pressure's too high. We can't study the core of the moon or Mars or anything else like that. So here's a chance to study the core of a growing planet from early in the solar system that is exposed to view. At least that's our hypothesis, and we want to test that with our instruments and our amazing spacecraft.
Perfect. And actually, speaking of the spacecraft, Psyche isn't the only experiment flying today. Hitching a ride on the Psyche spacecraft is the Deep Space Optical Communications Experiment, or DSOC. So, Jim, this is a completely separate technology demonstration.
Yeah, so we're used to radio communications with spacecraft, NASA's Deep Space Network. This will be the first time we'll use optical laser beam communication to try to talk to the spacecraft as it goes farther and farther out into the solar system. And that technology has been demonstrated out to the moon, but not beyond. So we want to use it out at Mars and get much better data rates, much higher quality data. So it's going to be a great test, and Psyche mission's just super happy to be carrying the DSOC.
Yeah, a lot of science packed into one mission. Now, Jim is obviously very knowledgeable. That's why we're inviting you to send him your questions about the mission. So just submit them online using hashtag AskNASA, then watch as we answer your questions live. And you can also interact with us by playing Psyche Bingo. Jim is ready to show you the card that you can get. You can get your very own by scanning the QR code we're about to bring up on your screen here. And every time you hear a bingo word on the broadcast, so for example, we have cruise, iron, core, Mars. Whenever you hear one of those words, just mark it on your card. And when you get bingo, you can show off your win on social media by tagging @NASA Solar System.
Right.
Now, Psyche the asteroid is sometimes called 16 Psyche, and that's because it was the 16th asteroid to ever be discovered. Now, more than 160 years later, scientists will soon study it up close.
16 Psyche is an asteroid that orbits the sun out between Mars and Jupiter.
The reason that Psyche is unique is that it is metal rich.
It's believed that it may be a remnant core of an early planetesimal that was formed in the very, very earliest parts of the formation of the solar system.
And after this planet started forming and this metal core formed inside of that, it collided with other bodies that then stripped off the rocky mantle, leaving this core in place.
This is the part of planets that we can't sample directly today.
It's too hot, the pressure's too high, our instruments would melt. Can't drill a hole that deep in the Earth or other planets. So how do we study the core of our planet?
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do, and it would be the first metal object that humankind has ever visited.
After launch, we cruise through interplanetary space for a number of years. First, we fly by Mars for a gravity assist that'll slingshot us into the asteroid belt. And then we're thrusting all the way from there to finally arriving at Psyche.
We'll go into 4 orbits to collect the necessary measurements that we need from our 3 primary instruments.
So our payload consists of a couple of imagers, which are cameras that take pictures of Psyche. Also a gamma-ray neutron spectrometer, which allows us to measure the elemental composition of the surface of Psyche. And then a magnetometer, which will allow us to detect any magnetic field that's left at Psyche.
If Psyche still has some sort of remnant magnetic field, that probably tells us it really was a core. It's a strong indicator. We also use the radio on the spacecraft as an instrument, so we can map out the gravity and map out the interior structure that way.
We're using a particular thruster technology, Hall effect thruster technology. They operate 5 times more efficiently than normal rockets, so they use a lot less fuel, and is what allows us to get into orbit around this asteroid.
Solar electric propulsion has been around for quite a while, and it has flown before, but we're continuing to push the boundaries. We're going to have big 5-panel fold-out solar panels that will provide the electricity for the thrusters, which use as propellant the noble gas xenon.
This will be the first time that Hall effect thrusters have flown in deep space.
Studying the evolution of a planetary body is a detective story.
There's a magic to when you actually are on the launch pad and you say, we're go for launch.
And you feel like singing and dancing, and you feel like throwing up at the same time.
Let's go discover things about our solar system that we have no other way to do. I think that it's fundamental to who we are and also who we should be. It's an incredible opportunity to be a part of the team making that happen.
I want to take a second to repeat what you just said in that video, feeling like throwing up and excited and dancing all at the same time. Is that how you're feeling right now?
Butterflies right now, very excited, but also super confident. This team is amazing that's putting this show together for us.
Yeah. And the scientist leading the investigation, we just saw her in that video, Lindy Elkins-Tanton. She's a professor at Arizona State University, where you also work, and you are also the Psyche imaging lead. Talk to us about that.
Yeah, so we are running the camera investigation on campus at Arizona State. We designed, built, and tested the cameras. It's a collaboration between Arizona State University, our our partner, Malin Space Science Systems in San Diego, and of course JPL, our colleagues at JPL. And we have a staff of faculty, staff, and students at Arizona State, and we'll be running the Science Data Center there for all the instrument data to flow through, including the imagers. So we'll be taking those shots, putting the mosaics together, getting them out to the public as quickly as we can.
I love that students are also involved.
Yeah.
Okay, T-minus 36 minutes and 12 seconds until liftoff of the Falcon Heavy rocket and Psyche spacecraft. Let's check back in with Daryl and Mick.
Megan and Jim, we are still green for weather and range, which is great news as you look at an orbiting shot there of the launch pad. We're here at Hangar AE at the Mission Directors Center. A lot of high-level folks behind us monitoring the mission, keeping track every step of the way. Mick, you did hear something, though, on the Range Ops Net that suggested that we had a recreational boat not in the box, which is the area of concern when the rocket goes up, but near the box. Nonetheless, they're going to get a visit from a Coast Guard cutter.
Yeah, absolutely. Being here, Launch Complex 39A, right here on the coast of Florida, you know, we have all kinds of things we have to look at, all kinds of weather constraints. We talked about the weather this morning. We have launch vehicle constraints we have to worry about, and we have range op constraints that have to be met. So the range team from the Space Force is monitoring all that and looking at it, and this is just one of those things we have to deal with.
We're also watching propellant load, the big operation as we lead up to the liftoff today, and in just a few seconds we're going to start RP1 load of the second stage. Let's listen in.
Stage 2 RP1 load has started.
With that call out, we're now loading the second stage with propellant, and following that we'll LOX load it. But the long pole in the tent are those 3 boosters that we're looking at.
Yeah, absolutely. We're about halfway filled with the RP1 and the boosters there as we look at the data on the screen, and LOX is continuing to flow in all 3 boosters to make sure everything's filled this morning for propellant. And second stage has started also. We're very excited to get all this propellant done. This is the most critical and long portion of the operation to get this vehicle tanked and ready for liftoff.
Very good. And the rocket standing tall today with a Psyche spacecraft encapsulated at the very top. A beautiful shot here on the Space Coast. The weather improving to 85% go. The Falcon Heavy with its 3 boosters going to lift that portion of the rocket that you see right there. Psyche is encapsulated inside, roughly the size of a van, inside that fairing, which protects it from the atmosphere.
Yeah, during ascent, we have to protect the spacecraft through all the Earth atmosphere, and as we get heading into space. And once we get into space, the fairing will be deployed, and Psyche will be out in the environment and ready for deployment.
And SpaceX planning on capturing those fairings today after they fall back into the ocean. Coming up, we're going to load the last of the commodities, LOX, into the stage 2. Stay tuned for that. For now, we'll send it back to Megan and Jim.
Okay, so that's what's going on with the launch vehicle. Now it's time to check on the Psyche spacecraft itself. For that, let's go to NASA's Jet Propulsion Laboratory in California. Raquel, so JPL is managing this mission.
That is correct, Megan. This is the Psyche mission support area behind me, where about 36 people are working. These are experts in operating the spacecraft. The team had a very early start on the West Coast. Many of them arrived around 3 o'clock this morning to start preparing for launch. Around this time, engineers have to turn on power to the spacecraft. And that's what they're doing here, transitioning to internal power using the battery that's built into the spacecraft. This battery is used until Psyche can get solar power when the solar arrays deploy. The team is also equipped with Lucky Peanuts. Eating them before major mission events is a tradition here at JPL. As we get closer to launch, I will talk to team members gearing up to take their seats in the mission support area you see over here. Back to you, Megan.
32 minutes and 3 seconds and counting to launch here at Kennedy Space Center in Florida. People from all over the world visit KSC on launch days to be part of such an epic sight. NASA's Jasmine Hopkins is live at one of those viewing areas now. Jasmine.
Thank you, Megan. Yes, we are on the balcony of the Operations Support Building 2 here at Kennedy, where we'll have a great view of the launch over in the distance. And joining us now is the Deputy PI for Psyche, Ben Weiss. Thank you so much for being here.
Super excited to be here.
Of course, I'm sure you are excited. You've worked on this mission for over a decade. So tell us how your journey started at MIT and how that got you here.
So we have a laboratory in which we measure the magnetism of rocks. And back in 2010, we were finding many meteorites, for some reason, were very strongly magnetized. They formed an ancient magnetic field billions of years ago. We were really perplexed, like what could be the origin of this magnetic field? And we were puzzling over this, and one day, Lindy Elkins-Tanton, the future PI of Psyche, was walking by my office, and I asked her, do you have any ideas about what this magnetic field could be? And she's like, I was just teaching a class about this topic right across the hall from you. So she came into my office, we talked about it for an hour, drew a bunch of things on the board, and then by the end of it, we came to the conclusion that many of these meteorites came from asteroids that had formed little metallic cores, just like what's in the center of the Earth. And the churning of these molten metallic cores generated a magnetic field just the way the Earth does. Okay, so we wrote a paper about this. Some scientists at JPL read the paper, and they invited us, also Maria Zuber was involved with that, and invited us out to JPL to see whether we might want to build a mission associated with this. And we thought about this for a second, like, yes. So then we went out there, and here we are 12 years later.
Right, it's great to see how you got here. So you're also speaking of this magnetization, and you worked on the magnetometer. You're the lead for that instrument. Can you tell us how will that role expand after launch today?
So we've been, until now, measuring little 1/4 millimeter fragments in our laboratory. Now we're sending a magnetometer out on a big spacecraft out to measure the magnetic field of a big asteroid. And we're hoping to make the first detection of a magnetic field around an asteroid.
Right. And Ben, as you said earlier, you have been working on this 12 years, so it's great to see that you are here today for this launch.
Surreal.
Of course, of course. Thank you so much, Ben Weiss.
Thank
All
you.
right, back to you.
Now, we just heard from Ben, Psyche's magnetometer lead. Why don't you tell us about what a magnetometer is? Why don't you break that down for us?
Megan, this is not just the host desk. This is the host desk of science. Because we're going to do a little demo here. This is the magnetometer.
Okay. So think of this as this magnet as a magnetometer.
That magnet is the magnetometer. I have 3 rocks here.
Okay.
This is a rock from my backyard, and these are 2 rocks from space. These are 2 meteorites from the ASU Busek Center for Meteorite Studies. And I would like you to be the magnetometer, the Psyche magnetometer, approaching this particular rock, which is a piece of granite. It's from my backyard in Arizona. Don't just take it for granted. It really is a piece of granite. Yeah. Okay, so not magnetic, right? Not much iron in that one. Now try this one. This is a so-called ordinary chondrite meteorite. It's a little magnetic. It's kind of it's sticking a little bit. Has a little bit of iron and nickel in it. It's kind of like the material you'd find. This would be crustal material, crustal and mantle kind of material. Now try that meteorite.
Whoa.
Yes,
oh my gosh.
Right. This is an iron. It's like massively stuck on there. This is an iron meteorite. This is part of the Canyon Diablo meteorite, which created Meteor Crater in northern Arizona. So you saw how strong that magnetic field is on this one, and so we'll be using the magnetometer on the spacecraft to try to detect that kind of magnetic field. And if we see that strong magnetic field, it is a good indicator that Psyche is an ancient core.
Okay, so that's what we want to do. We want to take this magnetometer, orbit the asteroid to see if there's that magnetic field. And so if we discover that, yes, this is likely a planetary core, what does that mean for us?
Well,
what can we learn from that?
It gives us an opportunity to study a core of a planet in a way we just can't. We can't go to the Earth's core. We can't study the other planetary cores. But here we can look at this object, which we can get its chemistry, we can look at the kinds of minerals on its surface, its geology, its density, its gravity field, and really understand some details about how cores form and therefore how planets form.
How planets form, our planet.
Our planet in particular.
Okay,
exactly,
thank you so much for breaking this down. Love the demo. Managing today's launch is NASA's Launch Services Program based here at KSC. It's responsible for delivering uncrewed spacecraft like weather satellites, telescopes. Many of those end up orbiting the Earth, but Psyche is going to go much farther. NASA's Daryl Nail spoke to an analyst about Psyche's unique trajectory into deep space.
Jermaine Oliver, good to see you again. How you doing? Well, this is your animation here. You're the LSP trajectory analyst. Show us now what is happening here with the second stage and the Psyche spacecraft on board.
We have the second stage and the launch vehicle together, and we're going through our first burn. This burn is going to get us to park orbit. During park orbit, we will basically loiter there until the trajectory lines up to get us on an outbound cruise to Psyche.
Okay, and so now you're going into that park orbit, and I notice this thing's moving around a little bit.
Well, we want to keep the sun about a 90-degree angle, but at the same time, we're doing what we call a barbecue roll, where the spacecraft will just spin to keep the temperature gradient across the spacecraft and the launch vehicle the same. You don't want the sun focusing on one particular area that could potentially damage any instruments or any hardware.
So it is continuing on the velocity vector, which we see here very clearly, and that 90 degrees to the sun. This is a long coast phase.
Yeah, about 45 minutes or so before we actually get into the injection burn.
Is there anything happening during this coast phase?
No, we're just pretty much just going through the barbecue roll, tracking the sun, keeping it 90 degrees away.
We're approaching now southern Africa and crossing that continent, but then getting ready for that second burn.
Right. When we finish crossing over the continent of Africa, then we'll start getting ready to do that injection burn where the vehicle will get into another attitude that will line up with the velocity vector.
And is that why we're seeing it start to swing back around?
Yes, you're starting to see that swing a little bit slowly right now.
Now the sun is on the other side of the Earth and starting to get into a shadow, so we'll actually be in darkness here as we approach the northwestern coast of Australia.
Correct. But that's not a concern to us. We still want to maintain the barbecue roll, as you can see. And as you can see right now, we're actually lining up to get to that velocity vector. And once we line up with that, we'll perform that injection burn.
All right, we see it now in the dark side of the Earth, starting to point into that velocity vector that you mentioned. And here comes our second burn.
Yes. You're about to see the second burn happen right now. It's about 2.5 minutes. This will inject us into the orbit that we will need to get to Psyche.
Second engine start, number 2. Your animation has a little vibration there as the engine's giving it the go, and then it cuts off.
Yes. And now, after this burn is complete, we will then get ready to go to the separation attitude. So you see the launch vehicle and the spacecraft get into an attitude where when we separate the spacecraft, the launch vehicle can then go into another attitude and perform a burn to get it away from Psyche.
I see it swinging back around, and here you've labeled Psyche separation.
Yes.
This is the moment where the second stage comes off the spacecraft.
Yes. At this time, we have separated from Psyche. Psyche is on its way. The launch vehicle is now performing a burn to get itself away from Psyche to include recontact, and Psyche will be on its way shortly.
Great. We don't want to run into the second stage with the spacecraft. It's got a job to do. And first, it's going out towards Mars.
Yes, it's going to do a Mars flyby to get that gravity assist, to slingshot itself over to the Psyche asteroid.
Help save fuel, get out to its destination. That's all a good thing.
Yes, sir.
Jermaine, thanks for showing us that.
Thanks for having me.
Time.
And we have space enthusiasts watching today's launch from around the world, and we have some recorded questions that they've sent in, while some are posting them live to social media. So why don't we get to some of those questions now?
Let's do it.
Don't be nervous. I think you'll get them all.
All right.
So here's the first one.
Hi, I'm Ezra, and I have 2 questions for you. How will you communicate with the spacecraft, and how did you come across Psyche 16? Thank you.
Oh,
wow.
Great first question.
Ezra's awesome. Those are great questions. So we actually communicate with the spacecraft using radio waves. So the spacecraft has a transmitter and a receiver, and it talks to NASA's Deep Space Network radio telescopes, which are around the world, in California, in Spain, in Australia. And these are enormous radio telescopes that can detect even very faint signals because we're going to be very far away.
Mm-hmm.
So we send radio signals back and forth from the ground. We send the signals up, giving the spacecraft the commands, what to point at and how to thrust. And then the spacecraft sends its data back down, telemetry, the pictures we're going to take, the data from the magnetometer and the other instruments.
Sure.
So it's all through radio. And his second question, how did we come across Psyche 16, was it was discovered by telescopes back in 1852.
Wow.
And it was the 16th asteroid that astronomers discovered.
Mm-hmm. Perfect. Can't believe so long ago, right?
Yeah.
Okay, let's take another question from social. Do we have a certain hypothesis as to what chemical elements or metals are present in the metal asteroid?
We do. We have a number of hypotheses because that's what scientists do. We pose hypotheses and then we test them. And one of our favorite hypotheses is that Psyche, the asteroid, is a lot like that metal meteorite that I showed you. It has a lot of iron and nickel and other heavy metal elements, and maybe a little bit of silicate rock on the outside. from impacts into Psyche over time. But we're really going to be especially looking for that iron and nickel to
Right.
try to make that case that it's a planetary core.
Hypothesis now, but you guys are going to soon prove it right
Test.
or figure out something else, huh?
Exactly, exactly.
All right, great questions, guys. Keep them coming, again, using hashtag AskNASA. Now, launching Psyche today is part of what NASA is calling Asteroid Autumn. The agency is conducting a lot of science on different kinds of asteroids around our solar system. So let's learn more about that with NASA's Jasmine Hopkins.
Thank you, Megan. Joining us now is NASA Administrator Bill Nelson. Thank you for being here.
Great day.
Yes, it's a great day to launch. So you were just in Houston, NASA's Johnson Space Center for the unveiling of the OSIRIS-REx sample return mission. So tell us about that. I mean, we are now about to launch Psyche, so why are we conducting these ambitious asteroid missions?
Isn't it interesting that asteroids are just fascinating to us because it gives us the clues to the origins not only of our solar system but also the universe. So we brought back OSIRIS-REx. We revealed it yesterday at the Johnson Space Center, and lo and behold, it has water in clay. And this is just on the outside of the container. We haven't even opened the container yet. It also has carbon. So if you got water and carbon, you got the building blocks of life. Now, this one, Psyche, we're going to a metallic asteroid, which is a core of some kind of celestial body. And as a result, we're going to learn all kind of new things, how these things fly through the solar system and they hit each other and they cause the evolution of what we have today, our solar system.
And Administrator Nelson, you know, we're also looking at the longevity of a mission like Psyche. It's going to take us about 6 years to get there. So what are the long-term effects of a mission like this?
RP1 load is complete.
Well, it's what you have to do to get there. We're using a fly-by Mars as a gravity assist, and that just takes longer to get there. But isn't that something? That 6 years down the road, we're finally going to get the revelation of what we're looking for, but we had to start planning it and building it even several years before this.
Right, exactly. It's great to see that we are here on this day for launch. Thank you so much for joining us, Administrator Nelson. Jim and Megan, back to you.
And we just heard that call out for stage 1 RP loading. Okay, we're coming up on another major fueling milestone now. Let's check back in with Daryl and Mick.
That's right, Megan. Stage 1 RP load complete, and so that completes the stage 2. Rather,
Stage 2
complete. But we're continuing to load RP1 in the first stage boosters as well as LOX, which is the long pole in the tent. And as we look at this view from our Kennedy Flight Operations team and their Airbus H-135 helicopters, which are out there for security purposes, and they have a camera on board, thankfully for us, you can see the LOX clouds surrounding the rocket, which it's quite a humid day here in Florida today, Mick, so it really stands out dramatically.
Yeah, that cloud is caused from that boil off we talked about, Daryl, that once we start loading, that cold locks into the vehicle. We get boil off that occurs to allow the venting of the tanks so that we can get as much LOX into the tank as possible for today's mission. We want all of that propellant to be able to get Psyche on its way on that trajectory that Charmaine talked to you about.
Speaking of LOX, we are getting ready to start loading LOX into stage 2 of the rocket, the upper part. And you can see that
Stage 2 LOX load has started.
And there's the call out. You can see that the strongback has been chilled as well. Now LOX is flowing up to the second stage of the rocket.
Yeah, now this will be the last and final propellant we need to get on board the Falcon Heavy this morning. We continue to load RP1 and LOX onto the first stage, and now that we've started stage 2 LOX, everything will be complete. Daryl, I did want to say Jim is excited to be answering the questions of those kids today. Me personally here in Brevard, I got Miss Stafford's class watching you and I today out at Saturn Elementary, and they're excited to be watching what we're doing.
Well, we thank them and all students who are tuning in today. We are hoping to have a liftoff here, and everything looks good for a T0 at 10:19 and 43 seconds a.m. Eastern Time, 14:19:43 UTC time. We will continue to track the tanking of this rocket, and we'll be back at T-minus 8 minutes to count down to liftoff. In the meantime, we'll send it back to Megan and Jim.
Now, once the Psyche spacecraft is deployed today, it's going to take 6 years to arrive at the Psyche asteroid. Why is that? Why so long?
Space is big, right? We live in a big solar system, and it takes a long time to travel between planets. 3 days to the moon, 6 months to a year to get to Mars or more. And so we are going on this looping trajectory from the Earth all the way out to Mars. We have to pass by Mars and get a little gravity boost from Mars. But then from there, we need to keep going out into the main asteroid belt, not all the way to Jupiter, but to about 3 times as far that the Earth is from the sun. And so it is just a long voyage, and it takes a long time to get there.
Yeah, and when the spacecraft gets there, it's going to observe the asteroid from different orbits, right?
Yes, so we will, this is a model of Psyche. We don't know that the asteroid really looks like this. We don't know it's exactly this size. We don't know its mass to great accuracy, right? So we're going to very cautiously approach it and get captured in its gravity in a very high orbit that's something like 33 hours long, and really start to characterize it, get to know the place. Hey, look, we're here. Let's get to know the place, right? And then over time, we'll slowly lower that orbit, and eventually we'll be down in an orbit that takes only about 4 hours to go around the asteroid, and that's when we'll get our highest resolution data and all that chemistry data that we're talking about, and we'll be mapping the magnetic field and the gravity field the whole time. So yeah, that's why it's going to take us a couple of years, 26 months, to do that primary mission.
Yeah, a long journey for a lot of science.
Yeah.
Now let's get to another update from Raquel, who's live with JPL in California.
Thanks, Megan. I am in the Space Flight Operations Facility here at JPL, which operates the Deep Space Network. It consists of 3 complexes with large radio dishes that let us communicate with spacecraft that go beyond the moon. Now, these 3 complexes are strategically located in California, Spain, and Australia. They provide two-way communication and also help us track and navigate the spacecraft so we can keep them on course. And right now, the Deep Space Network is supporting over 40 missions. The Psyche spacecraft is expected to first communicate with the radio antennas in Canberra, Australia. Then data will come here to JPL. The operations team will use it to track Psyche, monitor its health, and send commands as it travels to the metal-rich asteroid. Megan, back to you.
Now, riding along with Psyche is NASA's first demonstration of deep space laser communications. Let's bring back NASA's Jasmine Hopkins to learn more.
Thank you, Megan. Yes, joining me now is Jason Mitchell and Trudy Cordes to talk to us more about the deep space optical communications, also known as DSOC. So, Jason, how exactly do these laser communications work?
Well, Jasmine, so just like on Earth, where space users are voracious for data, and so most of that data on Earth is routed through fiber optic cables with lasers, as everybody knows. We do the same thing for space users in this concept for things like DSOC, except can't tether a spacecraft to a fiber, so you have to do a free space link. And with that, there's at least 3 challenges. There's pointing becomes a challenge. You have to point very precisely. Plus, the Earth distorts optical light, right? And so you think about a hot road or the horizon of a hot road on a hot day, right? Like today, and you see that shimmer. And then 3, the signal is so faint, you literally have to count photons. So we have to have these super cooled nanowire detectors that are cooled to just about 1 degree Celsius above absolute zero. But you put that together and we get a capability to deliver data 10 to 100 times faster.
Right, so what we're doing is pretty complex. And Trudy, your directorate focuses on future technology. So how can we use DSOC in the future?
Right, Jasmine. So as Jason said, 10 to 100 times more data we're getting back. So it's very enhancing. For our friends in science, more data means more discoveries. And then certainly with all the work the agency is doing around Moon to Mars objectives, DSOC now gets into the to Mars part of that. So humans to Mars, a very realistic type of system we could use for reliable infrastructure such as advanced communication systems is absolutely enabling and going to make humans to Mars and exploration a possibility.
Exactly. I'm glad you mentioned to Mars. Jason, you are understanding DSOC on a deep level, and actually there will be something called O2O on Orion for Artemis 2. So how are they working in tandem?
So thank you. So the optical to Orion will be another optical demonstration on that vehicle, and it will So they're different missions, so they're different implementations, but they do share a lot of common hardware, and they will use the same high-efficiency photon algorithms, right? Remember that photon-starved channel, got to count those photons. And that's how we'll accomplish that in injection or infusion into human spaceflight.
Right. And Jasmine, just to add on, so Jason and I had the unique opportunity to go over and see O2O installed on the Artemis II service module yesterday. It looks absolutely beautiful. We're excited about that. We're very grateful to our friends in Exploration for, flying that for us to get this to an operational capability. And Jason knows what we like to say in space tech all the time. What do we say, Jason?
Technology drives exploration.
Bingo, exactly what Jason said. So. Awesome. Great things to look forward to in the future. Jason, Trudy, thank you so much. Megan, back to you.
As you heard, laser communications will play a big role in our next mission to the moon. Let's see what else is already happening for Artemis 2.
It's a short package,
You would have thought it was launch day here at Kennedy Space Center just a few weeks ago. The Artemis 2 crew suited up in the historic Neil Armstrong Operations and Checkout Building. A test to practice a bit of what would happen before they lift off for the moon. Once their suits were on, they were off inside their brand new, fully electric crew transportation vehicles for the 9-mile drive to Launch Pad 39B. Kennedy employees waving to the crew as they drove by. At the pad, Commander Reed Weissman, pilot Victor Glover, and mission specialists Christina Cook and Jeremy Hansen took elevators to the top of the mobile launcher.
When we walked out that crew access arm, I just had images of all those Apollo launches and shuttle launches that I saw as a kid, and it was unreal. I actually had to stop and just stand a moment in the crew access arm to really let it all sink in.
The day's successful test ended in the White Room, their final stop before boarding the Orion capsule to the moon. That's your Artemis Moon Minute. If you're just joining us, welcome to live coverage of Psyche. Liftoff aboard a SpaceX Falcon Heavy rocket is now just 10 minutes, 13 seconds away. Atop in the payload fairing is the Psyche spacecraft, which weighs just about 6,000 pounds when fueled. That's about as heavy as a large SUV. It's made up of a body and 2 solar arrays in a cross formation, and when those solar arrays are extended, the spacecraft measures about 81 feet, or the size of a tennis court. It will be propelled by solar electric propulsion and will travel about 2.2 billion miles to study the metal-rich asteroid, also named Psyche. Now, Jim, you are one of the scientists behind this mission, a mission more than 10 years in the making. How are you feeling now with 9 minutes and 30 seconds to go before
my
launch?
goodness, I have butterflies the size of pterodactyls in my stomach right now. But really, I'm thinking about the team.
Yeah.
Right? I'm thinking about the hundreds, the thousands of people around the world, across the country, around the world, who have worked so hard to get to this point. Launch is the focus of a big team effort, and I know there's lots of folks out there on pins and needles right now.
Absolutely.
But also, I think we're also just super confident in the team at SpaceX, the team here at Kennedy, to get us up there into space and give us a great ride.
Yeah, and this mission could benefit planetary science for generations. So impactful.
Absolutely. I mean, we won't get to Psyche till early 2029, right? So you think about a lot of the kids watching at home today or in school today, they're going to be the researchers who start working with the data in the 2030s and beyond. And we're going to have that data set coming in for a couple of years and hopefully learn a lot about planetary cores, the Earth's core, how planets form, and all kinds of cool things like that.
Jim, I really can't wait to see what you all uncover. Yes. You can't wait either.
I can't wait either.
Pterodactyls in your stomach. That must feel awful. And now taking us through the rest of the launch countdown are Daryl and Mick.
Thank you, Jim and Megan. Appreciate all the knowledge we are getting about the Psyche
Center
mission
core
today.
RP1 load is complete.
And there we just heard a call out that the RP1 load is complete, and that's great news. We're continuing to watch as this vehicle is tanked with propellants, 2.8 million pounds of propellants, both liquid oxygen and refined kerosene, called RP1. We've got a number of things that we are going to be looking at as we count down to the final minutes, Mick, and one of them is chilling the booster engines, transitioning the power to internal from shore power on the ground to internal to the rocket, and the spacecraft.
Yeah, absolutely. As we're tanking the launch vehicle, there's also things going on with the spacecraft, and the spacecraft team is working all of their ops, transitioning to internal power, getting ready for this morning's launch. And we just heard that they confirmed communication with the spacecraft after a short transition, and we'll verify that they're on internal power here shortly. But things continue to look nominal for this morning's launch attempt.
And we're hearing as we go along updates about when each booster's RP1 is complete. And we will also hear when their LOX is complete. We're getting now down to the final filling of the boosters.
Engine chill has started.
Another key milestone is to pre-chill those engines. And that's critical when you're flowing super chilled liquid oxygen into them.
Yeah, we want to make sure all 27 engines are chilled to the right temperature, making sure once we get the chilled down RP1 and the densified liquid oxygen in there that things continue to work nominal from that aspect. So the team will continue to top off the LOX tanks and get ready for moving into terminal count.
We're getting ready to transition to internal power, both for the spacecraft and the rocket. That's coming up in just 20 seconds. We're watching the boosters as they fill. They are close to getting complete.
NY RP1 load is complete.
Another booster down for RP1. Actually 3 now. So now we move to the filling of the LOX and the completion for all 3 first stage boosters.
Okay, and I'm good to run that now.
Listening in for the switch to internal power. Beautiful shot of the rocket, Falcon Heavy.
Spacecraft is on internal power.
There's the confirmation. The spacecraft is now on internal power. The Psyche spacecraft that you see there encapsulated between those 2 fairing halves.
Vehicle tanks are pressing for Stromback retract.
So there we heard the team is pressing the Strongback to get ready to retract the transporter erector, or Strongback as you refer to it, away from the vehicle just prior to launch. We saw a shot there at the fairing, and that structure will move here in about 10 seconds as they retract that. Things are continuing to move pretty quickly here, Darryl, as the team preps for a T0.
Strongback retract has started.
So now let's take a view up at the top of the rocket where we can see the clamp arms. They will begin to release the rocket at just about the midsection of the rocket, midway up. We're also waiting for the NLM pole, which is coming up in just a few seconds. A final check with the NASA launch manager, Tim Dunn, by launch director Mike Taylor of SpaceX.
LD, NLM, countdown net. LD. The NASA Psyche team is go for launch. Copy, go for launch.
Great news there. The spacecraft team is ready. NASA's launch team is ready.
LOX load is complete.
Yep, and there we heard a call out for a LOX load on one of the side boosters is complete as the team continues to fill the tanks and top them off. Getting ready for launch. We should be hearing the other 2 side boosters finishing up along with stage 2
LOX load
LOX
is
load complete. And there we heard the other side booster is complete with LOX load, Darryl.
These 2 side boosters, they'll be coming back today, so if you're here locally, you're going to get quite a show. Boosters 1064 and 1065, which have flown 3 previous missions, 2 DoD.
Center core LOX load is complete.
And 1 commercial mission. They'll be coming back about 7.5 minutes after liftoff, so look to the sky for that, especially that entry burn and landing burn. They'll make a sonic boom that you can't miss.
Yeah, absolutely. We are looking forward to those two boosters coming back. And as we talked earlier, that center core will be expendable. We'll use all the propellants for Psyche today. And if you look at the launch vehicle, one of the unique things about that center core being brand new and expendable is you'll notice there's no grid fins or landing legs on that. And that is done by purpose to make sure we get the complete performance out of that center core for that trajectory that Jarmaine talked about to allow Psyche to perform its mission.
Always good to save some mass when you're flying a rocket to space. And those two side boosters, NASA has eyes for them for the Europa Clipper mission.
We do. Actually, the side boosters will be used on a...
Stage 2 LOX load is complete.
Stage 2 LOX load complete call out there. But those side boosters will be used on a Space Force mission later this year and or maybe early next year. And then we are looking to use those as our prime side boosters for the Europa Clipper mission in 2024.
And with that call out that Stage 2 LOX is complete, the Falcon Heavy is now completely tanked with 2.8 million pounds of propellants. Getting into the final minutes of the countdown now. T-minus 1 minute and 37 seconds.
Gas launch closeouts.
So you heard there the ground gas closeouts, and see that burst of LOX coming off the side of the rocket there? That is emptying out the LOX line in the transporter erector or strongback. Getting down to the final minute now.
Falcon Heavy is in startup.
Good call out that the Falcon Heavy is in startup. Now we're going to get the go at T-minus 45 seconds.
Go for launch.
We are go for launch. All systems are go to send the Psyche spacecraft to deep space.
30 seconds. Fifteen seconds.
And here we go with the final seconds of launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of Falcon Heavy and Psyche on a mission to a metal asteroid in deep space to study the building blocks of our planet's inner space.
Vehicles pitching downrange. M1D chamber pressure is nominal.
View there from the onboard camera on the booster. Beautiful shot there as it goes through the clouds.
Power and telemetry nominal.
Over here, Joe, the power telemetry are nominal. We're also looking at the data for all 27 engines.
Falcon is supersonic.
All chamber pressures look good, and Falcon is supersonic now.
Throttling down in preparation for max Q. A moment of peak mechanical stress on the rocket.
What will happen here
Max
is
Q.
The side boosters will be at full power, and the center core will be at a reduced power to go through max Q to reduce the pressures on the structure of the launch vehicle.
Coming up in 30 seconds. We'll start getting ready to have those boosters cut off.
Vehicle's looking good, pitching down range. All telemetry looks really good so far, Daryl. As we see a beautiful view of the Falcon Heavy and center core and side boosters there. Data is looking really good.
All 27 engines of the Falcon Heavy putting down 5.1 million pounds of thrust. Standing by now for booster engine cutoff for those side boosters. The center core booster will continue on.
Booster engine cutoff. Side booster separation confirmed.
Great shot there of the side boosters coming off the rocket.
MVAC engine chill has started.
And there we start the chill on stage 2 as we get ready for MECO on the center core. Stage 2 will continue chilling down, making sure the fuel and propellants are flowing through that MVAC, getting ready for ignition.
Those boosters will have 3 burns, 2 re-entry burns and 1 final landing burn before it comes back down at LZ1 and LZ2, landing zone 1 and 2 here at the Cape. Next up is main engine cutoff of that center booster. After that cuts off, there'll be a series of steps that will happen in close succession. Main engine cutoff. The center core stage will separate, and then we'll start the second stage burn, the first of 2 burns today.
There we see a shot inside the
shutdown.
That was a shutdown.
Looking
main
now
engine
inside
cutoff.
the booster. There you have MECO.
Stage separation confirmed.
And there it goes. You're looking at the second stage in front of you, lighting up its
MVAC
MVAC
ignition.
engine. Split screen now on your right-hand side.
Center core FTS is saved. Bermuda.
Calling out the communication stations. What a beautiful shot there, while we had it, of stage 2.
Daryl, we continue to look at the side boosters.
Bearing separation confirmed.
Boostback has been completed, and they're in extended coast right now.
And there go the fairings. Revealing Psyche to the atmosphere. You can see the fairing falling away back to Earth. SpaceX has their recovery vessel.
Vehicle is on a nominal trajectory.
Their recovery vessel, Bob, is out in the waters right now, looking to recover both of them. Getting a good burn now from the second stage. This lasts about 4 minutes. We are going out over the Atlantic Ocean, heading south towards southern Africa. On the right-hand side, you see the glowing engine of the stage 2. We've got 2 cameras there. On the left, we're tracking those boosters coming back down.
Yeah, we should see in about 20 seconds, we should see the booster entry burn, which would be the 1 engine on both side boosters.
Quite a clear image in space on the right-hand side. We've got clouds overhead on the left, but you can see at the center, we're tracking one of those boosters, also tracking the second stage, it looks like right there.
Yeah, all the data so far, telemetry is looking nominal. I see the telemetry chilling down the engines for that booster entry burn on the side boosters, starting up in the telemetry. Everything's looking nominal. The vehicle second stage is performing very well, and side boosters are coming back.
Boosters entry burn startup.
And there we just heard booster entry burn startup is happening. And seeing the entry burn getting ready to go on the side boosters.
Boosters entry burn shutdown.
And there we saw the booster entry burn on one and shut down. And there we see booster entry burn on the second side booster and shut down.
Next burn is the final landing burn. And for
TYNY FTS is saved.
And for folks who are in the area, you end up hearing that loud sonic boom, that thunderclap, just about the time they make landing.
Stage 2 is on a nominal trajectory.
You and I here at Hangar AE, just a couple of miles away from this landing zone, we certainly hear it and feel it.
Yep, and I see now that the side boosters are supersonic, transitioning to transonic.
And that's a shot of the booster through a thin layer of clouds.
We hear the call out for transonic. Landing burn has started.
Here it comes.
I don't know, Daryl, but that sonic boom was great for us. I'm sure Jim is excited over there. There's the second one. I'm sure the host desk over there is feeling that really well.
Literally, our monitors were shaking as both those boosters broke the sound barrier.
And we just heard booster landing confirmed, as we see on the screen, both
back
landing zone 1 and 2. Everything looks great. And then the call out for
Stage 2 FTS is safe.
Psyche 1, Stage 2 engine cutoff. So, Daryl, this will put us into that 45-minute coast that you and Jarmaine were talking about, allowing us to do
nominal
that
park
barbecue
orbit
roll.
insertion.
Absolutely, we're looking forward to that. And as you look at your screen there are the two side boosters on their landing pads, coming down more staggered than I'd seen them before, but nonetheless, perfect landings for them both. And now we will continue to track this right here, the second stage of the Falcon Heavy, along with the Psyche spacecraft right there looking forward. You can see the spacecraft on the right-hand side. It will be coasting now for about 45 minutes. And when we come back, we will bring you the moment of separation. In the meantime, we'll send it back to Megan and Jim at the host desk.
And if you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw a Falcon Heavy rocket launch off with Psyche, the spacecraft. Jim, speechless. Speechless. Actually, you weren't speechless during the launch because you were standing next to me, and he just kept on saying, "Go, baby, go!"
Oh, it was so powerful, so incredible. Just, the light, the sound, you felt it in your bones, just shaking us as this thing goes up.
I saw the range of emotions. Like, you were super excited, and then you got quiet. You got really quiet.
Well, there's a lot riding on this for the whole team, right? For all the hundreds and thousands of people that have been involved with this. And it's just, what a great ride so far.
Yeah. How did you feel also hearing and feeling those sonic booms? I was kind of worried because we saw it in the video, and we were like, are we going to feel it here? And all of a sudden, boom, boom.
Yeah. That was very exciting, very exciting. So, and it's just great job landing those boosters, because we want to reuse them for Clipper next year.
Yeah. Anything you want to say to the team? Again, as we just saw it lift off, you said all that hard work, all that time.
Yeah. No, this is just, it is a team effort, and, we're going to be collecting this data set and studying this planetary core for future generations. Really, it's going to be spectacular. Data, images, chemical data, magnet field data, gravity data, and really, we can't study the Earth's core any other way. So here's maybe how cores grow and what's happening inside our own planet.
Yeah. So the Psyche mission is going to explore the metal-rich asteroid, also named Psyche. And why don't we take a closer look at Psyche now? It was first discovered in 1852. We don't know exactly what the asteroid looks like, but scientists have combined radar and optical observations to generate this 3D model you're looking at right now. Shaped like a potato, at its widest length, it's 173 miles. That's about the same as driving from Houston to Austin, Texas. There's evidence of two crater-like depressions. It appears to have a significant amount of metal, and a day on Psyche lasts only about 4 Earth hours. So as Psyche's imaging lead, tell me, when can we expect the first photos?
We have to spend, once we complete the deployment, we have to spend many months just checking out the systems, propulsion system, communication system, computer system, everything, right? Communications. And part of that is checking out the instruments. So I think the magnetometer might get checked out first, because they're trying to detect some of Earth's magnetic field before we get too far away. And then in the weeks after that, we'll be testing out the imagers, taking pictures of stars, calibrating the cameras, getting the geometric correction just right, and getting ready for our eventual flyby of Mars, where we'll get lots of more great pictures as we pass by Mars. And then, of course, we'll start seeing Psyche as we get close to the end of this decade in late 28, early 29. It'll go from that point of light that we can see in telescopes to its own little world.
Yeah, the fact that right now it's so far away, again, orbiting the Earth between Mars and Jupiter, 3 times farther from the sun than Earth is, to be able to study it now up close. That's amazing.
It's very exciting, right? Yeah.
And the fact that we're going so far out to learn more about our home planet, I think that's so fascinating.
It is, and I love the fact that, you know, this is something we're going to share with the whole world, right? It's a point of light in the sky right now, but we're going to see it become a world as it gets bigger and bigger in the windshield as we get closer.
Perfect. Now, NASA's Jet Propulsion Laboratory in California is managing this mission. I also hear you're managing a very excited crowd right there.
Thanks, Megan. Yes, back here at JPL, there was so much excitement, clapping, cheering, high fives, and just take a live look from inside Von Karman Auditorium. We invited friends and family to come here today and watch the launch together. They're taking some photos right now, and when the launch happened, the whole room started clapping and cheering, and they are wearing their Psyche gear there. So Psyche may be off the ground, but its twin is still here on Earth. It will support testing on the spacecraft's journey to a metal-rich asteroid. Psyche testbed engineer Joan Tubungbanwa joins us now to tell us about it. Thanks for joining us, Joan.
Thanks, Raquel.
So how would you describe Psyche's testing twin?
Yeah, that's a great question. Psyche's testing twin is called the testbed, and it is located at our spacecraft assembly facility here at JPL, which is the same place where we built the Psyche spacecraft. Now, the testbed isn't something that you can just get from the mattress store, nor does it look like the spacecraft or a mattress. In fact, it's hardware that stays here, and if you look at the picture, it's connected by these snake-like wires that is designed to have the same software that the spacecraft is running with, which is also called its brain.
Now, Joan, you are about to start your shift here in the mission support area. What will you be working on?
Yeah, it's a super exciting time right now. The testbed is closely following behind the Psyche spacecraft as it progresses through the launch procedure. My shift begins when we first communicate to the spacecraft since liftoff, and this is done through something called commands. Now, commands are directions that we give to the spacecraft, which we tell it what to do and what kind of information that we need from it. The room will be making sure that the spacecraft is in a safe state, while the testbeds are sending the same commands and simulating the same data that we would get from the spacecraft. If anyone in the team or in the room was curious about a specific command, we would first test it on the testbed to see that we get the expected response.
Lots of work ahead. Now, Joan, you're not saying goodbye just yet. Tell us what's next.
Yeah, so of course I'll be celebrating a successful launch with my family, who's actually in Von Karman Auditorium right now, came all the way from New Jersey. October is also a special month because it is Filipino American History Month, and I was born in the Philippines, and so we'll be putting on an event that highlights both Psyche and our Filipino American team members. And lastly, I'll be following Psyche's journey, making sure that our testbeds are operating alongside the spacecraft.
Joan, thank you so much. I'm glad you were able to celebrate with your family. Megan, back to you.
Filipino Joan. And we were happy to host JPL's director here at Kennedy for launch. She's with NASA's Jasmine Hopkins, and they had a great view of liftoff.
Thank you, Megan. That is right. The crowd was so excited here on the balcony to see that beautiful liftoff of the Psyche launch. We're honored to be joined by Lori Leshin, director of JPL. So, Lori, this is a coast-to-coast mission from JPL to Kennedy. How do you feel to be here for launch?
So thrilling, so exciting to see that rocket light. There's nothing like it, and you see it, and then you feel it, and then the emotions really start.
Exactly. That was the perfect description of what we just saw. And there are a lot of emotions attached to this for you. The team at JPL has been working on this for years. So what do you want to say to the team at JPL and your partners about today's launch?
I am so incredibly proud of our team at JPL. I'm waving to all of you right now. I will say I was out at the launch pad a few days ago in the hangar with the rocket. It was laying down, and I just took a few minutes away from the group to stand underneath the fairing and think about all the thousands of hands and minds and hearts that have gone into making Psyche possible at JPL, at all our partners, and I just couldn't be more thrilled to represent them.
Exactly, and it's really like a relay race. You know, today's the beginning with launch, but you guys have 6 years before you get to Psyche. So
Yes.
What is next? What's the work being done at JPL?
So right now, it's all about picking up from the launch team and getting our spacecraft separated from the rocket, power positive, checking out all the systems, and starting thrusting in just a few months to get us on out to Psyche, 2.2 billion kilometers away.
Yeah, exactly. A lot to look forward to. Thank you so much, Lori Leshan.
Thank you.
Of
Go
course.
Psyche.
Yeah, go Psyche. Megan and Jim, back to you.
The Psyche mission is a collaboration between NASA's JPL, as we just saw, Arizona State University, and NASA's Launch Services Program in Florida. Let's meet some of the other people who made this mission possible.
At the end of the day, it's always a philosophical question, right? Of why are we in this universe?
Space just inspires everyone of different backgrounds, different nationalities. So I think it gives, in a sense, kind of hope for humanity.
As human beings, if we're not exploring, then what are we doing?
It's extremely difficult science and technology, but it's possible.
My name is Luis Dominguez, and my job is to assemble all the different components for the Psyche spacecraft.
I'm Julie Lee, and my job is to propel the Psyche spacecraft to a metal-rich asteroid.
Hi, I'm Benny Noy.
My name is Christina Hernandez.
My name is Veena Srikantamurthy.
And I'm making sure that we built a spacecraft that's ready to explore a metal world. What's really exciting about Psyche being a metal-rich asteroid is we haven't yet had the opportunity to explore a planetary core. And that's what we actually think happened to Psyche.
There is a theory that this metallic asteroid may be very closely related to the materials that made up the core of our own planet.
It could have been the remnant of a planetary collision billions of years ago in our solar system. All that's left is the metal-rich remnant.
Scientists hypothesize that by studying this asteroid,
We think that could give us a lot more insights on what our actual planet is doing.
So this is the Psyche spacecraft. We're basically looking at a spaceship that's going into space.
And welcome to High Bay 2 at JPL. We pulled together all the different components that everyone's building.
And so this is where we control the Psyche spacecraft. They dictate how things happen on the floor.
this is where I worked on the low voltage power supply for the Psyche mission. It's pretty exciting to watch something that we built with our own hands.
To see something that you've spent years on.
Launch and in a couple of years reach Psyche and send back science data.
We formed a really, really critical team.
The diversity of skill sets that each one of us in our community brought to the team to make this kind of impact to society is what inspires me to be an engineer in the space exploration sector.
Now, Jim, we just heard from some of your colleagues. Tell me, what does it feel like for you to be part of this team?
Oh my God, it's such an amazing team, Megan. And you saw some examples there. It's scientists working with engineers, all kinds of engineers, all over mechanical, software, communications, propulsion, power, every kind of engineering you can imagine. But it's also, we're working with managers, administrators, communications experts, educators. I mean, it's just such an amazing collection of people, a community of people that it takes to make this kind of thing happen. And I know they're all just super excited right now.
Yeah, and somebody said, what inspires them? What inspired you to be a part of Psyche and to want to go into this field?
When I was a kid, there were astronauts driving cars on the moon on TV. And it's like, I want to do that, and I've always just been hooked on it. Had a telescope when I was a kid, got to know the night sky, and just been really fortunate to be able to pursue all this as a career.
Yeah, I can still feel how emotional this is for you. Are you okay? We're back to excited. We're back to excited. All right, it's now been about 20 minutes since launch. Let's go back to JPL and Raquel again for another update on the Psyche spacecraft. And Raquel, the mission support area is working in shifts, yeah?
That's right, Megan. A team switched the spacecraft to internal power, and now that the spacecraft has launched, they'll pass the baton to a new team who will work to make the spacecraft fully operational. Joining us now is Psyche systems engineer Christina Hogstrom, who tested the spacecraft and can tell us what comes next. Good morning, Christina.
Good morning, Raquel.
So tell us what you'll be working on when you take over this workspace.
So right now we're waiting for the launch vehicle to get into position to let go of Psyche. And after that point, we'll be monitoring closely and waiting for that first signal from the spacecraft. Once it separates from the launch vehicle, Psyche is going to autonomously turn on its radios, deploy its solar rays, and then put itself into a slow spin at 1 revolution per hour. And that's to keep the temperatures uniform, which is why we call it rotisserie mode. Once it's in that spin, the antenna that's beaming the signal to Earth is going to be rotating in and out of our view. And so it could be anywhere from a couple minutes to a couple hours before we hear from the spacecraft. But as soon as we do, we'll look at the data, we'll make sure that it's still healthy, and then we'll start talking back to it. We'll command it to stop that spin, keep the antenna pointed at us, and then we will work to get it into its fully operational mode.
And we heard from Joan that there is a testing twin on Earth, but you actually tested the spacecraft itself. What kind of test did you do?
Oh yeah, we really put the spacecraft through the ringer. I helped to coordinate this test where we put the entire thing in a giant vacuum chamber. We sucked all the air out to simulate deep space. And then for 17 days continuously, we made it super hot, we made it super cold, we made it hot again to make sure that the spacecraft could operate in those extremes of deep space. And then there was another test where we put it on a big table and we shook it to simulate the launch vibrations that it's seeing today. As much as we can over and over, we've checked every wire, we've tested every function on the real spacecraft as long as it's safe for the hardware. Anytime we have a brand new version of the software that's on board the spacecraft controlling it, we always test that in the testing twin first to make sure it works. And then we still prove it out on the real spacecraft. And the whole process is iterative. So we start on the testing twin, we test something, we learn something, we fix it, we test again, and then we move it to the real spacecraft, we learn something, we fix it, and we start the process over. And that's why it takes us years to be absolutely sure that we're ready for today.
Sounds like it is ready for its journey. Now, you've been with the mission for 4 years. What is happening next for you?
Oh my goodness, it is surreal. This is my first flight project and I've just learned so much. I've had the opportunity to have a lot of different kinds of jobs on Psyche, from temperature regulation to fault protection, that's like autonomously detecting and correcting for problems. I even helped out with electric propulsion early on, and nowadays I'm on the operations team as kind of a systems generalist. I've seen this thing grow up from designs on paper to a robot that's on its way to space today, and I just am so super excited to continue on and fly this thing that we've worked so hard to build. The next 100 days are going to be pretty crazy for the operators. We're going to be checking things out, turning things on for the first time, making sure that everything's going swimmingly, and then we'll have a much more relaxing cruise to the asteroid, and I just can't wait to see what we find when we get there. I'll be on this journey to a metal world every step of the way.
Thank you, Christina. Back to you, Megan.
Now we asked for questions and you've sent them in. Jim,
Yes.
Are you ready to answer?
I am ready. Bring them on.
I wasn't ready to say that, but now I'm ready. Okay, so let's play the first question.
I am Paola and I'm from Serrano Elementary School in Moreno Valley, California. And my question is, how much time is Psyche gonna spend studying Psyche 16?
It's a great question that Paula asks. And so first of all, it's going to take us almost 6 years to get there.
That's right.
So we have to fly by Mars and slowly coast out, power ourselves out with those electric thrusters. And then when we get to Psyche, we'll start up high in this 33-hour orbit, and we'll spend a little more than 2 years, 26 months, slowly getting closer to the surface and getting higher and higher resolution and map this whole thing and get its chemistry and magnetic field and all that kind of stuff. So about 26 months.
Awesome. Great question, Paola. All right, let's take the second question now. How can an asteroid have enough mass and density to support a molten metallic core?
That is an outstanding question. And the answer, we think, is that this asteroid was part of something much bigger. Right? And so it had more gravity, and with that gravity comes internal heat, pressure, internal heat, and it's got radioactive elements inside of it as it was forming, and so it's really hot on the inside and it can get molten. And we think that the part we're seeing now is just what's left over after maybe a big impact, a grazing impact, knocked off the mantle and crust. We're going to test that hypothesis with the Psyche mission.
Okay, let's squeeze in one more question. This is Andy Zhang on H. How long did it take to research and develop this mission and the Psyche spacecraft?
Well, it's the better part of 10 years.
Yeah,
You know, we
wow.
saw earlier in the show that, you know, it all started with some scribbles on a whiteboard and, you know, folks thinking ideas about how can we learn about planetary cores? How can we figure out how planets form? We can't study the Earth's core. Hey, let's go visit a metallic asteroid that might be the remnants of a core. And so that idea from sort of 10-ish years ago became a proposal, a pitch to NASA in a competition that we won. To mount a Discovery class mission. And the spacecraft started getting built. We got selected in 2017, and then probably about 2018 or 19, we started building and testing the spacecraft. And here we are in 23, and it's off the ground.
And you know what? I just realized I never said congratulations to you.
Thank you. The whole team, it's really, like I said, everybody's just ecstatic right now.
Yeah. Okay, great questions, guys. Keep them coming using hashtag AskNASA. But right now, I need you all to take out your phones or get ready to take a screen grab if you're watching us on your phone. We're going to pull up another QR code for you, and this one will take you to NASA's Eyes on the Solar System page. This is really cool. You can track the Psyche asteroid's current location along with other asteroids and comets in our solar system. And once the Psyche spacecraft is communicating back with us on Earth, then you can also track its location too. Now, the Psyche spacecraft will gather new data that will be studied by researchers around the world, including the curator in charge of the U.S. National Meteorite Collection at the Smithsonian Museum of Natural History. Take a look.
When I was a little kid, I thought I wanted to be an astronomer. And I took a geology class, and there was just something about having a rock in your hand, something you could hold and feel. I thought, you know, we have rocks from outer space. Maybe I'll study those. I study meteorites. I love meteorites. It's like an addiction for me because I love exploring the solar system through understanding these rocks and the places they come from. Life on Earth exists on two heat engines. One is the sun, but the other is the heat engine below our feet. It drives the movement of the plates. It drove the differentiation of the planet. We've known for 2 centuries that our core was made of metal, but we haven't been able to explore it. We can't drill a hole that deep. We can't explore with any kind of submersible in the oceans. What we've been looking for years is a metallic asteroid, something that's very dense. Psyche is an asteroid 200 kilometers across, thought to be metal rich. Psyche is our way to explore our own planet. We have meteorites fall to Earth. Some of them are little tiny pieces. Some of them are the size of cars. But compared to Psyche, they're just tiny little specks of dust. When I first started as a graduate student, we had never visited an asteroid. Not any of them. Asteroids were points of light in the sky, and now they're real geologic places. They're places we can visit. More than the awe, more than the wonder, that we have this responsibility to do this right. And that's why this part is so important. What we're doing right now, designing these
Acquisition of
instruments,
signal,
that will
hard to
determine
boost
whether
up.
we get the data that graduate students 10 years, 20 years, 30 years from now will learn things about this asteroid that we can't even imagine today. It's the journey of a lifetime, and I didn't want to miss it.
Now, NASA has dubbed this fall Asteroid Autumn for all the fascinating things we have going on with asteroids around our solar system. For more on that, let's bring back NASA's Jasmine Hopkins.
Thank you, Megan. Yes, 'tis the season of asteroids. Here to talk to us more about Asteroid Autumn are Nikki Fox and Lori Glaze. Thank you for being here. We are so excited. So we are in Asteroid Autumn, but no 2 missions are the same. Nikki, tell us what makes Psyche unique.
Well, first of all, Psyche just launched. So, I mean, it's right, awesome. So, but Psyche is going to a metal-rich asteroid, and there are only 9 that we know of in our solar system, but Psyche is huge compared to the other ones. It's the size of Massachusetts. So we're going to go and actually visit a metal world for the very first time. We don't know what we're going to find, and that's what's so exciting about NASA science. Every time we launch a mission, we do unique, cutting-edge science, and this one is going to be absolutely no different. We cannot wait to get that out there, that spacecraft out there with Psyche.
Exactly, that was the perfect way to characterize it. We keep doing unique first. So actually, Lori, you were just in Houston as well as the administrator for the unveiling of the OSIRIS-REx sample return. So what are we finding with that mission? What is next?
That is an amazing mission, and as you said, I was just in Houston 2 days ago on Wednesday. It was absolutely spectacular to be there and share with the entire world kind of our first look at what that sample is. But really, it's the very beginning of the analysis process. We've got so much incredible science to do, but what was so unique about that particular sample was we're finding water in the sample. We're finding carbon, an incredible amount of carbon, more than we've ever seen even in the meteorites that we have here on Earth. So there's just so much new discovery to come. Keep tuned on OSIRIS-REx over the next several months, and I'm sure there'll be a lot more great new data.
Exactly, and we're actually not at the end of asteroid autumn yet. The Lucy mission is about to have a close flyby, its first asteroid encounter since launching in 2021. What are we looking to find from that?
So again, we're going to be going to an asteroid. It's a little one, so it's very, very different from Bennu, and it's different from Psyche, and we're just going to learn a lot because it's going to be the very first time that we've actually visited this new world. It also gives us an opportunity to actually check out the instruments and make sure everything's ready for when Lucy actually gets into the Trojan belt and starts the flybys in there. And I have to just give a shout out to DART. It's also part of asteroid autumn, and we just celebrated that 1-year anniversary of smacking that on the nose. But Laurie is going to tell you why Lucy is so important.
Yeah, so the Lucy mission, as Nikki said, of course, is going to fly by a little asteroid named Dinkinesh, and it's a main belt asteroid. But the real goal of Lucy is, at the end of this decade, is to explore several what we call Trojan asteroids. And they're Trojan because they kind of hide, right? You find the Trojan asteroids leading and trailing Jupiter in its orbit around the sun. Interesting fun fact, those asteroids, even though they're in Jupiter, the orbit that Jupiter's in around the sun is actually closer to Earth than Jupiter. But those asteroids are incredibly important for telling us about the early part of the solar system, where the giant planets were and if they migrated or moved over time. Those asteroids were picked up and held in that gravity field over time. And so the different asteroids we're going to visit will tell us about that history.
Exactly. A lot of great things going on with asteroids right now. Nikki, Laurie, thank you so much for being here.
Go Psyche.
Go Psyche.
Of course, go Psyche. Jim and Megan, back to you.
I love to see how excited they are. I also love that we do have this big screen there that's showing you the trajectory again of that second stage with Psyche. Now we are 33 minutes since launch. Once this Psyche spacecraft is on its own, the spacecraft will use solar electric propulsion to move through space. Now that's a super efficient system being used for the first time beyond the moon. First, Psyche's solar arrays will convert sunlight into electricity. That electricity will power the spacecraft's 4 Hall thrusters. Those thrusters will use electromagnetic fields to turn Psyche's propellant xenon into thrust, and that thrust will gently propel it through deep space while emitting that cool blue glow you just saw there on your screen. Now, Jim, when we're talking about gently, it is very gentle. Can you tell us about that?
It is very gentle. How gentle is it? It's so gentle. Hold out your hand.
Okay.
I have 3 quarters here.
All right.
It has about the same amount of force as those quarters.
Feels like nothing.
Nothing.
Absolutely
it's like
nothing.
a bag of feathers,
Yeah.
right? I mean, it's very, very gentle. So tiny but mighty, right? Because you exert that force over time, just continuously. So instead of just like one big main engine burn, it's just a slow, gentle process with that beautiful blue glow.
Yeah.
And that accelerates us out to like 125,000 miles an hour on our journey out into the solar system.
And that's essentially because even though it's nothing, if there's no atmospheric drag to push it back, it just keeps accelerating.
Exactly.
Interesting. Wow. Now, Maxar Technologies supplied Psyche's 4 Hall thrusters. You can see them there. Engineers estimate that if this mission used traditional chemical thrusters, it would have burned through about 15 times as much propellant. Now, Psyche is carrying 3 science experiments on board. Check out how they'll discover the asteroid's composition without even landing on it.
Psyche is a unique object in the solar system.
To us, Psyche is this really unusual body giving off really unusual gamma ray and neutron signatures.
Technically, it's an M-class asteroid out between Mars and Jupiter.
One of the first things you want to know is what's it made of.
So the Psyche payload consists of 3 science instruments. One of them is what's called a gamma ray neutron spectrometer. It's actually 2 separate pieces of hardware. One is the gamma ray spectrometer and the other one is the neutron spectrometer. Both combined study the elemental composition of Psyche.
If you know the surface composition, what it's made of in terms of iron and nickel and silicon and oxygen, you can then start to say something about its history and how it formed and how it evolved.
By using gamma ray spectroscopy, we can measure those elements remotely. We don't have to touch the surface. We don't have to dig into the surface.
For Psyche, we're building kind of what we call the Cadillac. It's a very high precision, high sensitivity instrument. It's very similar to the Messenger instrument.
That technology that we developed for the Messenger spacecraft gave us a huge head start going to Psyche.
For our types of instruments, we don't get to fly them very often. So when we actually get selected for something, that's a big deal for us, where we can, take what we learned from the prior missions and implement it now and make an even better instrument.
Our instrument is kind of like a camera without a telephoto lens.
In order to get our best measurements, we need to be relatively close altitude above the surface. That's what we call orbit D.
So we can form maps, global maps, of the elemental composition of Psyche just by flying around externally.
You have galactic cosmic rays. That's a fancy word for very fast protons. They come in, they smack a planetary surface, they bust apart the atoms in that surface, all the neutrons rattle around, and as they rattle around, they end up producing gamma rays and neutrons that come out. And the gamma rays have energies, and they're like a fingerprint. So if you get the fingerprint of different energies that says, is iron there, is nickel there, is silicon, and then how many of those gamma rays tells you how much of that element is there.
The first thing it takes to do a mission like this is a tremendous amount of institutional knowledge of all the different aspects, not just how do you build something, how do you aim something, how do you guide something, how do you get data from something, those technical aspects.
I feel like it's super important to have a team that you can trust, because you can guarantee that at some point something's going to go wrong, probably many things over the many years of a project. So already it's happened that in my process of learning about the science, I've made small changes to the design to help optimize and help meet the science goals.
We're kind of the last instrument to get its measurements.
And so there is a sense where you're on pins and needles until you get that data back, and then there's a big relief, there's big excitement, and then you get to work and trying to say, what does all this mean?
So we'll deliver some excellent science at the end.
And active checkout of the instruments starts about 6 weeks after launch. Jasmine Hopkins got to speak with NASA's chief scientist, Kate Calvin.
Welcome, Kate. Thank you so much for joining us today. So Psyche is going to take us to a metal world for the first time. What scientific discoveries are we looking forward to?
Well, the Psyche asteroid could be the metallic interior of the remains of a small planet. So this will give us an opportunity to understand how planets like Earth formed. So 4.5 billion years ago, all the planets on our solar system formed from the same cloud of gas and dust. And Earth has a metallic interior, but we can't bore down deep enough to see it directly. And so by visiting Psyche, we have this window to understand the processes that led to creation of planets like ours.
And it's going to take us a while to get to Psyche, about 6 years. So what are the long-term benefits of a mission like Psyche?
Well, from a science perspective, scientists are hoping that it'll help us better understand planetary formation, including the formation of planets like ours. But Psyche also has a technology demonstration along with it. So it'll be a test of communication from space, the next generation way of communicating from space. So the deep space optical communication will be the first test of laser communication from out beyond the moon.
Right, so we actually have two firsts attached to the Psyche mission, Psyche and DSOC. And once we get to the asteroid, we're going to be taking all these pictures, and then those pictures will be open to the public. So why is it so important that NASA makes science accessible for everyone?
So NASA makes its science publicly available, and we're working across the agency to make it more accessible so that more people have access both to the information, but also understand what we do with that information. And by opening science up to the world, we can do more and do it faster. So when we bring more people in and include them in our science, we can ask more questions. We can also answer questions more quickly. And this isn't just something we're doing with Psyche and with planetary science, but we're doing it across the Science Mission Directorate.
Exactly. We're actually doing it with Earth as well. We have the Earth Information Center now at headquarters. Can you tell us more about that?
Yeah, so Psyche is going to give us a little more information about metallic cores, and Earth has a metallic core. What the Earth Information Center tells us is a little bit more about what's happening on the surface of the planet and what we can see when we observe Earth from space. So we can learn about things like land use and land cover. We can learn about ice. We can learn about what's happening in the atmosphere and how that all impacts people here.
Exactly. Thank you so much for being here with us today, Kate.
Thank you for having me.
NASA and the Psyche mission team love engaging with the public and especially students. One program invited undergrads to share their creative works inspired by Psyche. So let's take a look at some of those submissions now.
Yeah. This is awesome.
That's so
I
cool.
love the way that we have artists and dancers and poets
Yeah.
and writers and playwrights, and this is spectacular, beautiful views. There's
the colors
there's our
for this
mission
one is
color
great,
theme right
yeah.
there. Yeah.
And I love 16 Psyche is scripted right there,
Yep,
really
with
pretty.
the spacecraft with its deployed solar panels.
Yeah.
Yeah, this is just beautiful stuff. Look at
Oh,
that.
that's cool. Look at the detail on Psyche there. Are your pictures going to look as good?
Just exactly. Yes, we certainly hope so. But boy, it's just beautiful fun to imagine.
Yeah, and it's so cool to see that both science and art, they can inspire one another.
Absolutely.
So,
Expect lots of signal, hard to beach stock.
Now, if you want to see more artwork and other projects inspired by Psyche, take out your phone and scan another QR code we have for you on your screen. This one's going to take you to psyche.asu.edu/get-involved. Okay, and I do know that you have other space arts. You're just so full of demos and props. I love it.
Space rocks, right? So I have a couple more space rocks. This is a slice of an iron meteorite. Let's see if I can hold it up to the camera there. It's a slice of an iron meteorite that's been polished. And you can see the beautiful grains. There we go. You can see the grains in it.
So
and this is a mixture of metal and silicate rock.
Yeah.
And so this might be not polished, but might be what the surface of Psyche is like.
Oh,
but it's also,
interesting.
it's just beautiful. People put these on their mantelpiece and in their rock collections. You can collect these.
You said make
as
it
well.
jewelry too,
You can
right?
make jewelry out of them, little earrings, a pendant, whatever.
That's cool.
I have another piece of space art. This is also a space rock. Let me hand this one to you. Tell me what you feel.
Oh, that's heavier than I expected.
Very
Wow,
heavy,
that took
right?
me
It's a
aback.
sphere that the artist has kind of carved out of a much bigger metal meteorite, and you can see all the little grains. And
Yeah.
it almost looks like a little mini Death Star,
It does.
right?
It does, actually.
And so people collect these and trade different ones with their friends, and so there's lots of ways to use space rocks for art too.
Yeah, thank you for sharing those. I really
Sure.
appreciate that.
Sure.
All right, it's now been about 44 minutes since launch. Our coverage is again going to take you through the deployment and first possible signal from the Psyche spacecraft. So let's check back in with Mission Control at NASA's JPL.
Thank you, Megan. Welcome back to JPL. We may be 2,500 miles away, but I can tell you the community feels connected. And here's a live look from Von Karman Auditorium. Just moments ago, it was packed with nearly 200 family and friends. This is where JPL hosts special events, and it's also where we display several spacecraft models. And there's a model of the Psyche spacecraft that I had a chance to see up close with payload manager Noah Warner. Take a look at why he says you can compare parts of the spacecraft to an electric car. Great to have you here, Noah. Tell us more about Psyche.
Yeah, I'd love to. So we're standing here with a quarter scale model of the Psyche spacecraft. And you can see even at a quarter scale, it's a very large spacecraft. The actual Psyche spacecraft is over 15 feet tall and 80 feet wide, and at launch it weighs over 6,000 pounds fully fueled. Let me point out a few key features of the spacecraft. You see up top here is the high gain antenna under this silver blanket, and on front is one of our 3 low gain antennas. Also on the front of the spacecraft is the NASA technology demonstration instrument called Deep Space Optical Communications.
Psyche will use a special kind of propulsion system. What can you tell us about it?
That's right. We use solar electric propulsion. That means we gather energy from the sun through our 5-panel solar arrays. We convert that energy into electricity and use that electricity to drive our Hall effect thrusters, 2 of which you see right here. They're 4 to 5 times more efficient than a chemical rocket. You can think of a chemical rocket almost as like a gasoline-driven, high-performance sports car with lots of acceleration, whereas our Psyche system is more like your highly efficient electric car that gets you everywhere you're going on the minimal amount of fuel. Hall effect thrusters use xenon as the propellant. They ionize that propellant and accelerate it out at tremendous speeds. They also generate this beautiful blue plume.
Wow. And right now, it's packed up in the spacecraft. How do we get it to look like we see it right now?
That's right. At launch, these 5-panel arrays are stored flat on the side of the spacecraft. And a series of cables, springs, latches, and dampers will choreograph that deployment such that the first 3 panels in line here will deploy first, and then the side panels will come out one at a time after that. And then the spacecraft will start looking for the sun and get those arrays pointed directly at the sun to get full energy. At that point, the spacecraft starts a rotisserie move where it rotates about once an hour, establishes communication with the ground, and then the operations team can start to check out the spacecraft and get Psyche ready for its journey.
So what are you looking forward to on Psyche?
I think I'm looking forward to the science investigation and frankly, the fact that we're going to a world that we've never seen with our own human eyes. We don't really know what we're going to see there, but I think we've got the exact right suite of science instruments to figure it out once we do get there.
Thank you, Noah.
Riding along on Psyche today is NASA's Deep Space Optical Communications Experiment, or DSOC. It will be the agency's first test of high bandwidth optical or laser communications between Earth and beyond the moon.
In our everyday lives on the ground, we use optical fibers for really high-speed communication, and that capability has been adapted for use in space near Earth. DSOC stands for Deep Space Optical Communications, which is using lasers to communicate at high rate. And the application of that to deep space beyond the moon is what the DSOC project is about.
Primary objective is to give future NASA missions the tools for returning data at much higher rates.
The signals travel at the speed of light, so they come just as fast as they do for the microwaves, but you could send more data in the same time of a pass for the same spacecraft resources. The notion of being able to communicate, have video to astronauts on Mars is actually part of the vision that NASA has for optical communications. DSOC consists of a flight terminal that flies on the Psyche spacecraft and then a ground network that has a station for transmitting up to the spacecraft and then receiving the laser signal down from the spacecraft.
Here we have to send a laser beam from Earth that the spacecraft has to receive, use as a pointing reference, and then initiate the communication link. So it's a very flight and ground joined at the hip kind of telecommunication system.
DSOC is being implemented as a technology demonstration to show that we know how to build terminals that can do this, with the idea that in the future they can be flown as part of the operational communication system on future missions. And we designed the terminal to operate out to about Mars' farthest distance. And Psyche on its cruise actually does a Mars flyby, so it's an excellent vehicle for the demonstration of deep space optical communication. DSOC is the first time that there'll be optical communication demonstrated beyond the moon.
The leap that DSOC is taking is huge. I can't express in words, what this will mean to actually see bits that were transmitted from deep space spacecraft received on the ground, and we can verify that, hey, we got the bits that you sent, here they are. Before that moment of elation and joy, there's a lot of work that we still need to do and think through.
And so this is a stepping stone for a future operational capability that NASA's committed to. There's a lot of activity in space and a lot of collaborative work that goes on, and it's very exciting to be part of.
MVAC engine chill, burn 2.
Now to tell us more about DSOC, we have its operations lead, Mira Srinivasan, with Jasmine.
Thank you, Megan. So Mira, we just saw a beautiful launch, but now the work really starts for DSOC. So what does mission success look like to you?
Right. So, the purpose of doing optical communications is to be able to transmit much higher data rates than what we can do now with radio frequency systems. So, for us, the bottom line or ultimate measure of success would be for us to demonstrate those target data rates that we've established for ourselves over the course of the mission. But just to kind of beyond that, I think this is a technology demo. So what we really want to do is learn And we have deployed all kinds of technologies, both on the flight side as well as on the ground side, in order to achieve these goals. So really, what we'd like to do is get enough data back so that we can understand, do our models work, how does our hardware perform, and what we can do to improve our operational concepts so that we can kind of mature this technology and bring it to the point where it can be fielded operationally. So that's mission success, is basically learning as much as we can.
Right, we're looking forward to that. And you're mentioning this data. So what information will DSOC be transmitting?
So what we're going to be focusing on primarily is this kind of test pattern data. This is what we've been using on the ground as we were developing the system, and so we'll focus on sending that initially. It's essentially like it's a test pattern, something that's pre-recorded, and it allows us to characterize the performance of the optical channel.
Right, and Mira, I mean, this is going to be a long-term mission for Psyche, but how soon do we expect to hear back from DSOC?
So provided that all the checkouts go as planned, approximately 40 days after launch, we hope to be getting some data down.
Okay, great. We're looking forward to that. Mira Srinivasan, thank you so much for being here today.
Well, thank you for having me.
Of course. Megan and Jim, back to you.
Now let's get to some social questions again. Jim, you've been doing a great job of answering them, so I hope you can continue your streak.
Let's do it.
All right, let's play the first video.
Hi, I'm Diego, and I'm from Serrano Elementary School in Moreno Valley, California. My question is, how long will it take Psyche to orbit the asteroid?
Good question.
Diego knows how to ask good questions. Absolutely.
Orbits.
Yep. So we start up very, very high as we approach the asteroid, go into very high orbit, and it's about 33 hours for the spacecraft to go around Psyche once, and we'll slowly lower that orbit, lower, down to about 4 hours. We're about 75 kilometers, maybe 50 miles or so above the asteroid at our lowest orbit.
Okay, and we do have time for one more question. We have this one from X, Space Case Sarah on X. What are you most excited about to learn about Psyche, considering how the Bennu sample was so incredibly cool?
Yes, boy, what a great success for that,
really
for
cool
the
too.
OSIRIS-REx team. That's spectacular. Of course, we're not taking samples from Psyche. We're doing what's called remote sensing, but we will be able to measure the chemistry, to look at the geology. We'll be mapping this asteroid just like the OSIRIS-REx team did with Bennu. So we'll learn as much as we can just short of bringing a sample back. So maybe in the future, decades hence, maybe we will go and bring some samples back from Psyche. But this mission will pave the way for that.
Okay, looking forward to maybe that.
Let's do it.
All right, thanks again. If you haven't sent in questions yet, there's still time. Again, use #AskNASA. Okay, we've been following along with the Falcon Heavy's second stage as it continues its journey out with Psyche. Let's bring back NASA's Daryl Nail and Nick Wolfman
burn 2.
for the next operational milestones in this mission. Guys, go ahead.
Yeah, there you just heard it, and you can see it. The engines start for the second time on the second stage of the Falcon Heavy rocket, now flying through space close to the country of Australia. And you can see it there. We've been tracking it all along, watching the fuel get prepped and prepared to restart that engine. Make this burn roughly about 2 minutes and 9 seconds.
Yeah, this burn's very important to get Psyche on its way. And Daryl, as you said, we've been tracking that. And as throughout that 45-minute coast phase, there have been call-outs for different ground stations that have been used around the United States, or around the world, actually, to track this second stage. And you and I have been continuing to watch that telemetry. And this vehicle so far has performed very well today, and looking forward to this final burn to get ready for spacecraft deployment.
Those tracking stations that you mentioned, as we've heard them called out throughout the broadcast, also helpful with bringing us this picture right here, that high definition video pictures from space, which we greatly appreciate seeing and are able to show you exactly what's happening. As the spacecraft approaches the northwest coast of Australia, it will continue flying over the Indian Ocean. We will get ready to end that second burn and then prepare for the big moment, Mick, and that's separation of the Psyche spacecraft.
Yeah, and that's what Jim and I know all his team are excited about. We are too. Great successful launch today, watching that Falcon Heavy come back, those two side boosters land. But it's all about the Psyche spacecraft in this mission, and that's what we're very happy to be doing today, to deliver this on orbit and get Psyche on its way. And we are so happy to be a partner with JPL and the Psyche team to do that. So very looking forward to that video of separation.
So the burn about to come to an end here in just a few seconds.
MVAC shutdown.
There you hear the good call out of the MVAC shutdown, still glowing red though in the cold darkness of space. We are in orbital night on the other side of the planet from where we launched this morning.
Nominal payload deploy, orbit insertion.
Confirming the orbital insertion there.
So yeah, it's confirming that we hit our mark exactly on that trajectory and where we needed to drop Psyche, get ready to drop Psyche off, as Jarmaine had pointed out earlier in a segment on the trajectory. So that's really good to hear that Stage 2 performed perfectly today, and we're getting ready for this last little coast prior to Psyche deployment. As you can see, the spacecraft right there on the front of Stage 2.
Yeah, there it is, the Psyche spacecraft attached to the second stage, the camera looking forward where we can see that will be the image we will be looking at when separation happens, and we'll be tracking that as it goes along, of course. We lifted off today at 10:19:43 a.m. Eastern Time, 14:19:43 UTC time, and we've been flying for almost an hour now. And again, the teams at JPL certainly paying close attention, along with the both here in California, or there in California and here in Florida. They're locked into this moment about separation.
Yeah, spacecraft team I know is excited about this moment, and the launch vehicle team is actually continuing to watch as they secure the launch pad here, and everything's going well. So teams are excited for this moment here. This is what it's all about, spacecraft separation.
And here is some of that team at the Mission Director Center in Florida, and now you're looking at the team in Pasadena, California at JPL, the Jet Propulsion Laboratory. This is the control room where they will run Psyche. We'll be monitoring the second stage and Psyche as they fly, and we'll be back in just a little bit. But for now, we'll send it back to Megan and Jim.
Really loving those live views that we're seeing of the spacecraft there. So why don't we actually, head back on over to JPL in California to hear what's happening now as they check out the spacecraft.
So the SpaceX speak, you just be like, it's green, we're okay.
Thanks, Megan. We are about 1 hour after launch, and now everyone at JPL is eagerly awaiting the next major milestone. Here is a live look from our mission support area. There was a shift change just a short time ago. Right now, they're preparing for initial acquisition of signal from the spacecraft. I'm joined now by Psyche Flight Systems Manager Mark Brown, who is responsible for spacecraft development. Thank you for joining us, Mark.
Thank you, Raquel.
Now, you were part of that countdown shift.
Yes.
What was it like witnessing launch with your team?
Oh, it was very satisfying. The end of a long road for us developers, but then this is the start of the journey, that the spacecraft's going to take. We're very confident in how the spacecraft's going to behave. We've done all the testing and analysis that relates to this. There's always a little bit of nail biting that goes on with these things because you can't exactly test that exact ride to space, but we're quite confident. The other thing I would say is that we're relieved to have gotten to do launch today. There's a lot of moving parts with these launches. As you know, we got people in Florida, people here, people working off shift times, and just knowing that we're launched will allow everybody in their personal lives to kind of settle down. We now know what the schedule will be, going on from here. So.
And what can we expect to see next from Psyche now that it started its journey?
Right. What's really going to happen just in a matter of moments is we separate from the launch vehicle, and now the vehicle's really on its own. On the ride up, it was on battery power. So when we get those solar arrays deployed, we'll be looking to basically get to the arrays on sun, okay? And then we'll be looking for that first signal. And the first signal isn't necessarily a data stream like you would think about. Anybody of you that, in your house, if you're looking for your Wi-Fi, you can see that signal, but you don't necessarily start getting, Google and on the internet, right? So the carrier comes in first, and then we'll kind of sync up and we should get the data coming in.
And what kind of data will you expect to see from Psyche?
There's a range of, first of all, I'll say, is that, the spacecraft exists to carry the science instruments, but the science instruments are hibernating. They are off for launch. So we don't really see anything from the instruments themselves. We get some temperature data and, and some health data on those instruments. But what we're probably most interested to see is, you know, are we power positive? Is the battery recharging, or are we still draining it? And then we're also going to be looking for, are all the temperatures kind of within safe limits, nothing too hot and nothing too cold? And those will be big indicators of, you know, that we're good to go.
Well, thank you so much for that information, Mark, and joining us today.
Thank you.
Back to you, Megan.
Okay, well, as Mark said, we are soon expecting to see the Psyche spacecraft separate from the Falcon Heavy's second stage. We have an animation of that right now. Let's bring back Daryl and Mick. Everything still tracking, guys?
It certainly is, Megan. We are watching now, as you can see on your screen, the Psyche spacecraft looking forward from the second stage, as well as keeping a track on what's behind it as well, going between the two views. But
Acquisition of signal, Hobart.
And there's just a call out that they've reached their next tracking station along the path that Psyche is taking. But the big show is right there. That shot right there, Mick, the Psyche spacecraft pointed into space. We are in orbital nighttime, currently flying. We've overflown Australia, approaching Papua New Guinea, where we are tracking a separation time in just about in just a few seconds. Stand by.
Psyche payload separation confirmed.
There it is. The Psyche spacecraft going off into deep space.
That is
2.2 billion mile journey.
Yeah, I'm going to tell you, that is an amazing shot right there. It is so, I'm so excited to see that. Probably not as excited as Jim, who's up at the hostess right now, but that is an awesome shot to see Psyche leaving the stage 2.
You see the team right there in the lower left-hand right corner. They are anxious as they see their baby go off into space towards an asteroid named Psyche, same as the mission. As you look at that Psyche spacecraft, you see the large diameter circle, which is where it attached to the payload adapter. That circle down at the bottom, that's a low-gain antenna. And that low-gain antenna will play a key role. It's got 3 of them. There's 2 more on either side. So if that one is the bottom, there's 2 on either side. It will play a key role on when we get that carrier signal that we just heard JPL talking about.
Yeah, I'm going to tell you, in all my years of doing launches, Daryl, that was a beautiful sight. I think that's the longest I've been able to see a spacecraft deploy. So that's an amazing job by the SpaceX team on that camera work on the second stage.
And so we'll keep tracking this as well, listening in for that signal. Momentarily, we're actually going to put up a waveform monitor where we're actually going to be looking at the signal, whether or not we can see, actually looking to see whether it comes in or not. That is a little more inexact because, as he described, JPL in the earlier interview, that spacecraft is going to start rotating as they try to lock that low gain antenna to a receiving station back here on Earth that JPL will see.
Yeah, I like the way he described it, like your Wi-Fi in your house, right? You find a signal, but you don't quite start receiving data and getting on the internet yet. That's kind of what they're looking for from the spacecraft here, that low gain carrier signal that they can know where Psyche is and that they've made contact with it, and then they'll continue to monitor that and so that they can then sync up and start getting the data and then starting their next 100 days of operation with the Psyche spacecraft.
All right, we just saw the Psyche spacecraft separate and go off on its journey into deep space towards the Psyche asteroid. We are now monitoring its progress to see when it makes that carrier signal back down to Earth, but we'll send it right now back to our other Earth partners, Jim and Megan.
Well, Mick had said it. Mick, there was a lot of excitement here when we saw Psyche separate. But now I feel like there's a little bit more of an anxious feeling because now we're waiting for the carrier signal, right?
Yeah, so we've just seen this beautiful wild animal released into its native habitat.
Okay.
Right? This is where that spacecraft belongs. This is what it was built for. Let's see if it phones home and we get it going.
Yeah, exactly. Yeah. And while we wait for that, why don't we take some more social questions? Again, we've asked people to send them in using hashtag AskNASA, and we've gotten a couple of them. So why don't we show the first one now?
Hi, my name is Santiago,
a student from Tetra Porter Elementary School. My question is, why do you guys think Psyche is a core of a planet?
Wow, these kids are asking awesome
I
questions.
know, I love seeing
Santiago,
kids
that's
ask
a
these
great
questions.
question. So there's three pieces of evidence. One, we can see the colors, the way that the asteroid reflects sunlight. Looks a lot like those metal meteorites I showed you earlier. Also, astronomers can bounce radar waves off of Psyche from the Earth all the way out to the main asteroid belt, and they bounce back and very, very highly reflective, not quite like a mirror, but clearly suggesting metal. And the third piece of evidence is that when we can watch its orbit wiggle a little bit when Mars passes by, or when Jupiter passes by, or when Psyche passes by another asteroid, its orbit changes a little bit. So we can get its mass, we estimate its volume, also from telescope data, and that gives us an estimate of density. And its density, it's heavy. It's not that light granite rock, right? It's more like that heavy metal meteorite, that sphere that you held, right? It's really dense. So we know that there's a metallic component in this one as well. It's one of the densest asteroids we've been able to measure.
So you guys do know a lot about it. Now it's about going out there and checking out to see if your hypotheses are correct.
True. It's still a point of light to us in the sky. We have to get close to it to turn it into a real world.
Okay, let's take another social question now. This one is from Christelle on Twitch. Is there a chance that the asteroid contains water?
That's a great question.
Yeah.
We don't really think so.
Okay.
But it might have some material on the surface that is more silicate rich, not so metallic. Maybe it was hit by other meteorites like the one that we just brought the samples back from OSIRIS-REx, which turns out to have a bunch of water in it. So there could be little places on the rocky parts of Psyche that have some water, but probably as a whole, we think it's mostly just metallic.
Got it. Jim, thank you so much for answering those questions, and thank you to everyone who sent questions in. Okay, so to recap, the Psyche spacecraft has been deployed and is now floating out in space on its own. The launch team is looking to confirm a signal from the spacecraft. So Daryl and Mick, how's that looking?
Yeah, Megan, we've been flying for 1 hour and 8 minutes now through space, and there you see, I believe we have
Yep, I see
signal.
See the spike right there of the low carrier signal and the JPL team clapping. It looks like that little spike in the center right there is the low carrier signal that they're looking for. So that is good news that we've received that carrier signal, and the team will begin their work.
And what you're looking at there in the lower left-hand corner of your screen is the receiving station for JPL, and they got that carrier signal, which came off of Psyche's low-gain antenna. It sent out that signal. There's not a lot to that signal. There's no data, no telemetry, just a basic signal that says, hey, I'm here, I'm out in space.
Yes, basically, as Jim said, phone's home, lets them know where they are, that they can start working to get their stuff set up and start acquiring data later on and beginning that next 100 days of operations that they need to do. So, very excited for the Psyche team, spacecraft team, successful launch of a Falcon Heavy today, and now they have contact with Psyche, and they can begin the work they've been working on for the last several years.
As for the spacecraft, what it's doing now is getting into a mode to deploy its solar arrays. They're going to get those arrays out, get it pointed in the direction of the sun, get that spacecraft power positive. And this is a process that, as they go through that, ultimately will lead to a lock on a telemetry signal, potentially several hours from now, where they can get a data stream and learn about the health of the spacecraft.
Yeah, absolutely. That's what they're looking for, and that's what's exciting for them to get these things started. So very excited to watch that and bring things to a conclusion here for this mission as we are, Daryl. But the Psyche team still has a lot of work ahead of them.
That's right. They got to go fly by Mars, which is their first destination in about 3 years.
3 years, yeah.
And another 3 years after that, they'll be on their way to Psyche. So, of course, congratulations to the JPL team, LSP, NASA, SpaceX, everyone who's participated in making this mission a success. And I appreciate you riding shotgun here, partner.
I appreciate it, man. Another great successful launch. And I would say to Jim, congratulations, my friend, and go Psyche.
All right, we'll send it back to Megan and Jim at the host desk.
Thank you, Daryl and Mick. Always good to do a broadcast with you
Those
guys.
guys are great. Those guys are awesome. Yeah.
Now, Jim, you are Psyche's imaging lead, obviously so invested in today's mission and all these milestones. I'm telling you, sitting next to you, it's like riding a roller coaster. So like deployment, you're like, and then it's back down to the carrier signal. And then we get the carrier signal and you're like, and now we're waiting on solar array deployment. That's the next big thing, right?
Right. We knew even when we were writing the proposal many years ago, there would be 2 early critical events, right? We just saw one of them, the beautiful SpaceX launch and KSC team delivering us to the right path. We're going the right direction. The second one is that deployment of the solar panels. You saw that they're all kind of folded up against the side of the spacecraft, so they need to spring out and deploy so we can go power positive and get that sunlight turned into electricity to run our mission.
So a lot still to watch, but you're okay. You're feeling okay so far.
Yes.
And I know, again, so many others are sharing in your relief and excitement. Let's get some more reaction from Mission Control at NASA's JPL in California. Raquel, I saw some cheering there once Psyche's carrier signal was confirmed.
Megan, that's right. Now let's take a look again into the mission support area. Like you said moments ago, we watched the team cheer and celebrate. Some of them were even standing up for it. But there is still more to come. And we are now joined by Lena Hutchinson, who is part of the Psyche launch team. Now you're the launch activity lead, which means you're in charge of verifying the spacecraft and it's behaving as expected through launch. So Lena, lots of work leading up to this moment. What does this mean for the team?
It's really exciting. It's really special to kind of know that the spacecraft is alive and healthy. So that first little blip that we saw was our first indication that separation was successful, and we are on our way to deploying our solar arrays. And hopefully we'll soon start to see actual telemetry where we can start verifying power and temperatures and a lot of other things like that. So it's really exciting, and for me personally it's really special because this is the first mission that I have actually worked on that I got to launch since I started at JPL. So it's extra exciting because now we're finally here, we're in space.
Well, congratulations on your first mission, and the work doesn't end here. So tell us what's next for Psyche and you during its long cruise.
Yeah, so as we keep going, we will start checking out all of our instruments, all of our hardware, making sure that everything survived the launch and is doing okay. So we'll be checking out all of the data and making sure that everything is doing well. And I will be continuing on with Psyche. I will be continuing as we checking out all of these instruments and helping out and supporting the team with all that work.
Now, in your support role, we understand that the first 24 hours may look different from the first weeks or months. What's that like?
Yeah, so our main goal right now is to make sure that the solar arrays are deployed and that our telecom system is working, which means we can actually start sending and receiving data and commands. And that is like the most important thing to focus on right now, because those are the things that we absolutely need to be able to continue on. We have to have power and we have to be able to talk to the spacecraft. So that is the main focus for the next day or so. And then as we continue, we'll start checking out all the other hardware and making sure everything's looking okay.
Great. Thank you so much, Lena. Now, Megan, that will do it for us here at JPL. The mission support area will continue to wait for acquisition of signal, which is expected to happen within the next couple of hours. So we'll send it back to you in Florida.
Great, Raquel, thank you so much. And back here on the Space Coast, you can see that Jim and I are not alone. We are now joined by Diana Calero from NASA's Launch Services Program. Today, she was filling in on console as the Assistant Launch Manager for Psyche. Important role, another successful mission for you guys. Congratulations.
Yes, thank you very much. It was great. We had a great count. Actually, it was pretty clean. We got over a few issues early on in the count, but then everything was very quiet. Everything was very clean. Of course, we had some worries about the weather coming in with the 30% violation, But then we got, right before prop load, we got a great assist there by our launch weather officer for the 45th Space Quadrant, giving us a 15% chance of violation, which was awesome.
Yeah.
So going in, everything was nominal. There was a little bit of drama there, maybe in the last 5-6 minutes there when spacecraft was transitioning to internal power and they weren't quite getting their telemetry. They couldn't verify it, so everyone was holding their breath there for a little bit, but then they got it and everyone's like, everyone let out their breath at the same time.
Gosh.
But we had a beautiful launch, as you saw.
Yeah.
The recovery went well. Everything has been nominal second stage. Separation was nominal, payload fairing, everything looked great, and just waiting to hear that the spacecraft getting their signal and was
Yeah.
power positive. Again, this doesn't go easily. We have a great team assembled, the SpaceX team, the LSP, NASA team, the Psyche spacecraft team, including Arizona State University, JPL, everybody. It was incredible. The range, 45th Space Quadrant again, giving us lots of weather updates.
Sure.
You know, we had to stave off the first attempt, but everything worked out great.
Yeah,
Super team effort. Now, this was NASA's first primary science mission launched on a Falcon Heavy. So why did NASA choose this rocket?
So for this mission, based on the size and where it was going, right, interplanetary mission, we needed the performance to be able to lift that up. Falcon Heavy had that performance, met the requirements. It was great. Falcon Heavy, when we selected this mission, was a fairly new vehicle coming out for SpaceX. So we had to certify this vehicle, actually. NASA, we can't launch until we certify the launch vehicle. Psyche mission is what we consider a Class B mission, very important science mission. So we had to certify. It was a multi-year effort, again, by a huge team, that we had to look at qualifications, had a lot of boards looking at scrutinizing it technically to make sure it was a low-risk vehicle for this mission. So that culminated in the certification, Cat 3 certification of this vehicle before we can launch it.
Thank you for choosing the vehicle. It was a wonderful show with the launch and then the side boosters coming
Please pass
down.
along our thanks for a great ride.
Yeah, thank you. Thank you. So it was an honor, and we're proud to be able to launch Psyche and looking forward to getting some good science and being able to use that.
Yeah, how does it feel to be part of that, to be part of Psyche's journey out to discover things about our own planet, hopefully?
It is. I'm so proud to be able, just a small part of that, right? I mean, how many years to get Psyche to this level, right? And then even though we worked this mission for many years before, I feel it's just a small part of what that Psyche, that cog in the wheel to get that Psyche and that science back, right?
Yeah.
How long it's going to take to get there, and then come back with the science, and then use that science in a way that's going to benefit
Very
mankind.
important cog. Very important.
Teamwork, guys.
Teamwork's the only way.
Thank you, Diana. Now, before we sign off this morning, let's take one last look at today's spectacular launch.
15 seconds.
And here we go with the final seconds of launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of Falcon Heavy and Psyche on a mission to a metal asteroid in deep space to study the building blocks of our planet's inner space.
Vehicles pitching downrange.
M1D chamber pressure is nominal.
A view there from the onboard camera.
And that'll do it for us here at Kennedy Space Center for this live coverage of NASA's Psyche mission. A huge congratulations to everyone involved, and a big, big congratulations and thank you to everyone who participated, especially you, Jim.
Oh, that's very sweet. It's such an amazing thing to be part of this team. And I'm thinking of the team right now, right? I mean, hundreds, thousands of people around the country, around the world, that all have to come together and make this happen. So many skills, so many sets of experiences, so many stories, and so much adversity. This was done during COVID.
I was just going to say challenges.
COVID,
yes,
right?
yes.
And people overcame that, and now our spacecraft is on its way, on its journey.
And so what's next?
What's next is that we spend the next few months, we've got to deploy those panels and get power positive.
I thought you were going to just
yes,
take a time to breathe.
Sure,
Jim.
there'll be a little partying, I'm sure, responsible partying. But that we have to spend the next few months checking everything out,
Still
getting
a lot of
everything
work.
working,
Yep.
and all the systems, all the instruments, all the calibrations, all that kind of stuff. And we are just super excited to get going on this.
Yeah, literally. Cannot wait to see what you guys uncover, because, again, we are going to uncover something about our own planet.
It's
so
true. It's
thank
true.
you.
And we're taking data for generations to come. So
Yeah.
it's very exciting.
So thank you for posing the question.
Thank you for having me on the show.
Oh, gosh, of course.
We've got our purple and orange going on here.
Yes,
so
yes.
it's all good.
We're Psyche proud. And now you can continue to follow along this mission by scanning the QR code on the bottom of your screen. This is the one last QR code, guys. It'll take you to nasa.gov/Psyche. And together again, we are going to discover the mysteries of both Psyche and our home planet. And please join us again tomorrow at 11:30 a.m. Eastern for NASA's coverage of the annular eclipse, the Ring of Fire, a celestial event you won't want to miss right here on NASA TV. Everyone, have a great day.